Okay, here we go. Hello, everyone. Today is April 13th in the year 2024. We're having our bi-monthly fourth meeting. And let me see, we have a good collection of presentations. And I'm excited to hear everyone giving us interesting news. I always find the meetings very helpful and very inspiring. So our first speaker is Bill Ragsdale, and Bill, I already saw you are with us, so the stage is yours. And yeah, let's hear what you can tell us.
Well, good morning, gentlemen. Delightful to see you all today. By way of introduction to some of the newcomers, I'm Bill Ragsdale, was the founding president of the Fourth Interest Group, 1978, and led it for 4 or 5 years, and had a number of other activities. I'll introduce this talk by the closing, and then we'll have the closing later on also. But the slides you see today will be posted or are now posted as PDFs at GitHub/Bill Ragsdale. That's GitHub/Bill Ragsdale. And the value in this is that the links that are shown here are pretty well live links in the PDF. So if you want to see the reference material, get the PDF, and you should have links to all the sources. So what we're going to cover is some 40, 50 years of the archives of information on Forth on the internet. And I'm going to make a bold statement to lead with to catch your attention, and that is that no other computer language other than Forth has the breadth and depth of information and history as we do have with Forth. There is no archive on Pascal, no archive on C++, on Python, you name it. Where can you go to find in one place, one archive that covers 40 or 50-year history, except in Forth? So by tracking through what I present today, you will gain access to what I calculate is approximately 620 examples and lessons of Forth, which are examples with code, with explanation in fourth dimensions over this time period. You'll be able to retrieve the material by subject and by author from sorted indices. You will have access to the slides and notes of every Silicon Valley Fourth Interest Group meeting for the last 22 years. That's a 22-year archive that is online. And you'll have access to the video of every Silicon Valley Fourth Interest Group meeting over the last 16 years. The first segments are the handouts, and the second sequence is the actual live videos from the meetings. And of course, I'll point out the last 5 or 6 years are taken from Zoom meetings, which are very well done, very well presented and edited. Also, you'll have access to JFAR, which is the Journal of Forth Applications and Research, which is the University of Rochester. Formal, which is the Forth Modification Laboratory. This is a series of conferences held for about 12 years at Asilomar in California. Also, information from the Rochester Forth conferences and the Euroforth linkages. Again, where else would you find an archive like this at your fingertips? So a little background on where the material came from and how it's organized. This is an early picture from 1978 or thereabouts of the organization of the Fourth Interest Group. On the back left with the beard and the shiny forehead is Dave Bolton, the late Dave Bolton, passed away some time ago. In the shadow in the back, on the back right is John James. And on the left front is, with the heavy beard, is Kim Harris. I'm in the center with the Fourth Dimensions t-shirt on. And on the right in the red t-shirt is Dave Kilbridge, who is our treasurer. This group started under an oak tree in the Stanford Student Union in about this 1978 time period. So in the background, starting in June, July 1978, we published the first edition of Fourth Dimensions, and it continued for 23 years through 21 volumes until 1999. An amazing publication history, and that is the major information retrieval area. Having Fourth Dimensions published and online opened the door to the flood of fourth-based publications, which we'll see over the following 46 years. The online archive of Fourth Dimensions covered from 1978 to 1999. Vierte Dimension in German covers from 1984 to the present. The Journal of Fourth Applications Research covers about a 5-year time period. The formal conferences is 1980 to 1992, 12 years. The Eurofourth conferences are very well documented from 1985 to the present. And the Silicon Valley Fourth Intergroup meeting videos go from 2008 to the present. And as I mentioned, the Silicon Valley meeting slides, PDFs covered 1999 to the present. So here are elements of the access. Again, if you download the PDF on this, you'll, in the blue underlined areas, you'll get the actual links to the material. We also will discuss how you can get this access directly from forth.org. So the first resource available is there is a keyword and author index of Fourth Dimensions, volumes 1 to 15, that are available as PDF and as Word. And there is an author-only index from volumes 1 to 15. After volume 15, from 16 to 20, there is a scanned table of contents. So in this case, on one PDF, you will see the 5 or so years of content, but you have to look at the table of contents to find what you're looking for. The entire scanned issues of volumes 1 to 20 are online as a PDF. And I'll note that the last published issue of Fourth Dimension has a link here, which was it was not printed. It was not a printed issue. It was the concluding issue, which was prepared and distributed by email and posted here. The entire archive can be seen at www.archive.org. And then you search for Fourth Dimensions. Archive.org, if you're not familiar with it, is an amazing research. It takes snapshots of the entire internet of every few days, weeks, months, years, so that you can roll back a website over time periods and see snapshots taken at that time. It's an amazing resource that was put in about by Brewster Kahle, who's a friend of mine. Brewster Kahle put in. He got a $50 million purchase from Amazon, from AOL a few years ago, and he took that money and invested it now in building the Internet Archive. So here's our history. Fourth Dimensions. This is my library of Fourth Dimensions, which it turns out is only about 3 feet away from me on a pile on a table. And year after year, I continue to say I'm going to organize it and scan it and file it away, and it still sits there. But the online version is much better organized. Here's a snapshot of volume number 1, issue number 1 of Fourth Dimensions from June, July 1978. It was done on a Selectric typewriter. My wife was the editor for the first year. The second issue looks a little bit more professional. And this was August, September of 78. And you can see the content of the issues. We use the academic journal format, so the table of contents is on the cover. And the page numbering continues through the year. So you start at page number 1 on January, and you page numerically sequence through all of the issues, 6 issues for the year. About a year later, on volume 1, number 5, you can see Roy Martins became our editor. Roy Martins was the business manager of the Fourth Interest Group for about 5 years. And the notice the cute artwork on the left-hand edge, which shows it's taken off after indirect length threaded language. In 1982, Leo Brody became our editor. He had worked at Forth Incorporated for a number of years as a technical editor, and he became an independent consultant this time. So about his half-time job was being the editor of Fourth Dimensions. And again, the cover artwork has been improved at that point under his leadership. Marlon Oberson was an alumni also of Fourth Inc. And when he retired, the Fourth Dimensions employment was his bridge to private consulting. And again, we have somewhat of a artwork change. And finally, the prettiest cover of all was under Marlon's leadership, starting in about 1990. Probably the most attractive cover of the bunch. This is volume 21, 22, some years later, 1999. This is the online version that Marlon put together as his last step, and Skip Carter arranged to have it published. And we'll mention Skip Carter later. He is our tremendous resource and host, because he hosts the Forth.org website. Here are some of the links on how to access material. Your starting point, I'll put out a big notice here. These websites were instituted 20 some years ago, back in the late 1990s, and they are not menu driven. There are no drop-down menus. These are all link driven. So it is more difficult to find the material. You have to go to a page, find the link on the page, and then click on that. And so the content is not terribly organized in a hierarchical top-down way, but you find the material in blocks with links page by page. So if you go to Forth.org, and then on the home page, you will see the link to Fourth Dimensions, and that will then get you to the next stage, which is all of the issues. So on the next page, you'll see a link that says scanned issues of volume 1 to 20. If you follow that link, you get to the page that's shown at the bottom. In this case, you now have the links to each page. The black numbers on the left are the volume numbers, and then there are 6 inches a year, and so the blue underlined numbers will get you to that particular issue. So you can go any volume, any issue by these links. And again, you've had to make 3 link selections starting with Forth.org. This is a way to get the indices for these issues. Again, from Forth.org, the FD Fourth Dimensions page, the PDF index will get you a PDF version of the 20-some years of, or about 16 years of content. And if you want them in Word format, there's a link for that. What you'll then see in these downloaded indices is the sorted, in this case, by keyword. So on the extreme right-hand column, beginning with algorithms, going to applications, you can see the content year by year, issue by issue, with the author name, the volume, issue, page, and title. Later on the same document, you have the sort by author. Well, in this case, you can look under last name, and you can see that Ash was the first in the alphabetical sequence, and then Abu Mustafa came later, then down to Ackerman, Altness, and so on. So you can find material contributed by each author. For the last few years, the last 5 years, you have the scan table of contents. In this case, you have to scan through them, but again, they're organized with the full description of the content of the article and its title, author, and so on. So the usage is to go to those links, pull down the index in the format that you want, and you can either get the PDF or the doc format. And I will point out that this old doc format, the Word format, which is pre-2016, the current versions of Word seem to give up on the doc formats. They need a converter tool to go along with them. And so I open them up with LibreOffice. LibreOffice handles the old format perfectly well. But again, the current Word versions need a helper add-on to be able to read those old formats. And so on those downloads, you can search by the keywords author and subject. Pulling a little information out from the author index, we see that Henry Laxon has 19 entries. In other words, he wrote 19 articles over that time period in fourth dimensions, and he is the author of Laxon and Perry 483, which occurred in the late 1980s. I guess early 1980s. Dr. Ting was the second most prolific author with 18 entries. John James with 16, and myself with 15 entries. And Glenn Hayden, who did 479 with 12 entries. So these are some of our historic figures. The kinds of things you could find in these publications are quite advanced, quite interesting. There are articles on CRC calculations, a number of articles on extended precision math. There are some architectural discussions of alternatives to indirect threaded code. I know a couple of articles on dynamic memory allocation, so on. So these are very, for their time, very contemporary issues in computer science development. Also reading this, you will be able to see how Forth itself has evolved over 50 years. There are 3 generations of Forth standardization. There's Forth 79, there's Forth 83, and then there's ANSI Forth. And more. When you get into the formal conference proceedings area, the first thing you will see is just Splash, which is the announcement for the reference index, which was published in 1993. And on this page, there is a link that will get you to the indices. There, as far as I know, there are very few formal proceedings that are available as PDF. I think 1 or 2 issues somewhere along the way you'll find on the internet that are PDF, but we have had no PDF versions of all of the issues. I have 2 or 3 issues, but that is still a task to be done. At forth.org, you'll see the link to the article reference. So this is right on the home page. When you click on this, you will then get the content index from 1980 to 1992. It's organized similarly to the one that was done in fourth dimensions. So you can see it's organized by keyword. In this case, then the first one is Forth Applications in Industry. It's by Guy Kelly, and it was done in 1990. And it is 3 pages long. It starts on page 3 and it's 10 pages long. So it nails down exactly what, where, and how. The sorting by author gives you the formal proceedings by author. And again, it started by Abu Mustafa and then goes down to Will Baden. And you can see Will Baden was very prolific. At any given Forth conference, he would often present 2, 3, 4 items. And quite interesting, quite challenging. So Will made major contributions to Forth along the way. He's also a very innovative thinker. He would come up with unusual twists. And then finally, there are the formal conference proceedings by date. So in this case, the very first start would be year 1980, page 3, and so on. And this will step through page by page, year by year, through the Forth proceedings. Larry Forsley and his wife, Taya Martin, organized a nonprofit organization at the University of Rochester, New York, and they started the Journal of the Forth Applications and Research. published it for about 5 years. I believe there are 4 issues per year. The material is available in total full form at forth.com. This is Forth Incorporated site. So if you go to forth.com under Forth Books, they have extracted the article. So it is not in journal format. It is article by article by article, but it's the full comment, full content, text and illustrations from the journal for every issue. Silicon Valley Forth Interest Group assumed the mantle of Forth Interest Group. Forth Interest Group ran until, I guess, about the late 1980s or early 1990s. And then when it faded away, Silicon Valley Forth Interest Group took over its activity level at serving the Bay Area, the Northern California Bay Area. It has maintained the YouTube videos over time. So there are a total of 415 videos posted on YouTube. And the channel has a total of 1,150 subscribers. So in this case, go to YouTube and search Silicon Valley Forth Interest Group. They are posted, I believe, by reverse date. So when you go to that channel, you will see the most recent information first. And this is a link to those videos. So if you go to forth.org and to Silicon Valley SEFIG, at that page, you will then see a link to those meeting videos. So you can go directly to YouTube, or you can go to link to these videos. And at the forth.org page, the organization of the indices is shown here. Again, most recent first. When I prepared this, the most recent was November of 2023. And here you see the content of the topic, the presenter, the format, in this case video, and the duration. So in this case, this was 4th day 2023, and the last video in line was 54-minute chat with Chuck Moore, who was our annual speaker every year on the November 4th meeting. So again, some 12, 15 years of videos all online. From that same page, then you can click on the meeting slides. And so if there are handouts or PDFs from those meetings, they are shown under the links from past meetings. And if you click on that, again, you see the index online by reverse date order. So in this case, it's my takeoff on this was from 2023, working backwards. 12 meetings per year. The Vierte Dimension from Germany has run from 1984 to the present, so it's the only continuing online publication, written publication. It's available, I believe, in written form and PDF online, and is about 80 to 90% in German and about 10 to 20% in other languages. Very thorough in maintaining the current technical developments in Forth. It has a similar structure as the access for Forth Dimensions. If you go to that website that's given there, starting at the forth-ev.pe, then you can go by volume number. The black numbers on the left are the volume numbers, and then 6 issues a year underlined in blue. The Euroforth conferences, again, are accessible from euroforth.org. And year by year, the conferences are shown. If you click on the year number at the left, that link will get you then to the presentations and proceedings from those conferences. Again, I want to reinforce what a rich selection of material has been archived for us. The presentation is very thorough. You can select to view indices by the subject, author, and date, and you can download the text from the links on the right. So we're winding up now. The credits I would like to offer for the people who have generated this material over time, Fourth Dimensions, over quite an extended period of time, started with my wife as the first editor for a year. The Roy Martins took over, then Leo Brody, and then Marlon Overson. And these are all people who have, over a long period of time, made a great contribution toward the documentation of Fourth. Larry Forsley and Teo Martin managed and inspired the Journal of Fourth Application Research and the annual Rochester Conference. The Fourth Modification Laboratory Conferences were managed by Kim Harris and Bob Reiling here in Northern California. And the current Silicon Valley Fourth Interest Group Archive is managed by Dave Jaffe, who was our link to Stanford University, by George Perry, who was our early technical manager. Kevin Appert currently is the chairman of the group and organizes the meetings. And Brad Nelson each month does the Zoom recording. And then he breaks the Zoom presentations down by content, posts them, and indexes these. So that the fourth Silicon Valley Fourth meeting is on the fourth Saturday of the month. And usually by about 4 o'clock in the afternoon, Brad Nelson has the material posted online. So thank you for your rapt attention on this. Oh, and the last mention is Skip Carter. Skip Carter deserves a huge debt of gratitude. He is the manager and owner of the Tegeta Network Security, and he hosts the Fourth.org website and has for the last 20 years or so, and indirectly the subdomain for the Silicon Valley Fourth Interest Group. So we thank Skip Carter for his contributions. So to conclude, I want to acknowledge all of the organizations and users that have left this huge archive for our benefit. And I challenge you all to go in, look around, and find something interesting. If you want a current project to work on in Fourth, find one of these older articles, expand it, bring it up to date, and present it. And the starting point, as always, is Fourth.org or the Fourth.com, which is Fourth Incorporated, or the link that I gave you to the German Fourth websites. And again, to conclude, this slide presentation is in PDF form at GitHub/Bill Ragsdale. There are several folios there. I think there's about 7 or 8, and so you might have to click down to look at all of the folios that are presented. So, do we have any questions or comments?
Thank you very much. Well, what a great overview. Other questions?
Now, Sven? It's muted. I think we're all stunned into silence. That's good because it means I have resolved all the questions. You all absorbed knowledge, and that's what counts.
Yeah. So I maybe just have a small remark. Because of Wolfgang Strauss, the German Force magazine is actually the latest issues are translated to English as well. So if you go to the page that will present it and you look carefully at the latest issues, you will see that there is also English versions, and you can download the PDF. So all the German language articles have been translated. Yeah.
That is amazing. Is that machine translated or human
No.
translated?
Yeah, well, half and half. So the attempt is done first automatically, but then proofread afterwards and made 100% consistent. So it takes some time, but there are some volunteers to actually do that. And Wolfgang drives this, and I think if you enjoy the English translated version, then let Wolfgang know either directly or via myself, so that he is encouraged to continue that.
I congratulate you all on that. It is absolutely fantastic. Really, really, really good. And it shows you the man-machine combination. You know, do a machine translation and then touch it up. And that is really good. Thank you.
Yep.
Yeah, thanks.
All right. Are there any other comments, questions? So I only can encourage everyone to have a look there. It's really an amazing resource, as Bill said. And I'm really happy that we took the effort to gather all this together and make this available. Because going back, looking at what the community did in the early days is really very helpful, and to reconsider things that were done on the small limited things and computers that we had in the early times can now be re-examined, and on a much larger PC, or even on an embedded system that is much larger than a PC was at that time, can be really be valuable to incorporate into your force programs. So yeah, it's a treasure. Yeah.
And what's so important is that the material has been captured contemporaneously. That is, it's captured at the time it's been presented, because it is so much harder to go back on an archive basis and reconstruct it later. So we have to thank our predecessors for the last 12 or 15 years who month by month have captured the material and posted it. Thank you.
Yeah, yeah. So I think that is really great. All right. So then let's see, we continue with our next speaker. And I must say, I should have checked if Virgil is in the conference. He probably will let me know, but Virgil, are you with us? No, I'm browsing through the participants. I don't see him actually. So is Virgil, are you here talking or want to talk about Collapse OS? Doesn't seem to be the case, but I saw Travis, which is our next speaker then. And if Virgil appears later on, then we just switch the talks. Travis, are you prepared to talk about Zepto-Force and the implicit compilation? So I see Travis, but he might be under the impression of not being on schedule right now. So let's see.
Oh, I'm here.
Ah, you're there. Great. I'm excited. So are you ready? Could you talk right now?
You just wait a second.
Sure.
Let me share my screen. Okay.
Yeah, we see that. Thank you very much. Go ahead.
What I call implicit compilation is a new feature of Zepto-Force where you can do things like this. Wait a second. And this, you can't see it here, obviously, but this is toggling the LED. But if you notice something close about it, I didn't define a word for this to execute within. Rather, this is being executed outside of any word definition. Well, how it works is that if the Zepto-Force interpreter sees a word such as begin or. Okay, let's say -1, true if who else bar that. Or if is another one, it'll immediately start compiling an anonymous word. And then once it reaches a matching syntax, let's say in this case, then it immediately executes the word, and then it rolls back the code that it compiled. And you can see that it doesn't use any more RAM. Like first, this is, you can see the main text dictionary free. And then I'll do, this time I'll do false. And then I'll do unused again. It didn't actually use any RAM in a persistent fashion, even though it is defining a word when it's executing it. And you can, and this isn't limited to a single line of input. For example, I can do, instead of the single line execution I specified earlier, actually I'm gonna end this one because I got to implement something. Okay. I do 0 begin, E not while do. It's only when I hit repeat that it starts doing this. And when I hit enter, it stops. And you can also do it with things like case, for instance. Let's say we have 0 case, 0 if who, no, oh, not yet. Who, end of, 1 of bar, end of, 2 of bads, end of, the end case, and then it's only when I enter end case does it call, does it execute that. And this whole thing, to me at least, solves a lot of a seeming gap in a lot of ports where you can't do conditionals or loops or stuff like that outside of the word definition, which from my having used, let's say, Python in the past, Python doesn't have such a limitation. And there's no good reason why Forth shouldn't have such an limitation either. Of course, there's certain things you cannot do with this. Like, this might not crash in this example, but it's not something you want to do. And what it's doing with it here with end here is that is equivalent to true until, except for it doesn't actually compile any conditional branch. It's just to match begin to allow a scope to be defined and nothing more. But this, for instance, will result in undefined behavior. Like, let's say I do this again. And what happened here is that I overwrote the code for the previous lambda that I defined. Because after each time implicit compilation is complete, it rolls back the here pointer in RAM. But then I overrode it again by defining new code. And that's why it only executes the printing bar rather than both foo and bar. Which, of course, that's a catch that that's a catch. So you don't want any like lambdas or like to last outside the scope of the implicit compilation. Because it'll be the pure pointer will be rolled back and then it'll be later overwritten. I think it's going to reboot here. And that's pretty much what implicit compilation is. Once you actually think about it, it's not all that exciting, but at the same time, it's a, as I mentioned, it's a filling a gap in your typical form. So I think I'm done with my presentation. If anyone has any questions.
Yeah, thank you very much. And my question would be, can inside the control structure, if you have loops, can you also compile things or add to the dictionary so that you can maybe
No,
initialize a
you
data
cannot
structure?
add to the well, you can't add to the dictionary because what happens is that it saves the here pointer and then it allows the user to compile whatever they want after that.
Mhm.
And then once it's done, it rolls back the here pointer to its original position.
Mhm.
So if you define something like a word internally, that word, the here pointer will be rolled back. But if you change the latest pointer, which is pointing to the most recent word, that is likely to cause problems. Because implicit compilation assumes that it can just roll back anything that the user had compiled after it.
Mhm. Mhm.
Hence
Yeah.
the fact that the unused, when you call it unused before and afterwards, the dictionary size left for RAM is exactly the same.
I see. I see. Yeah. I played around with this concept well, many years ago. And what I did is I moved the temporary definition that you create to some other location. So, and then reset the dictionary already. And then when you execute, it could actually add programmatically wise to the dictionary, like initialize the data structure. Inside a loop, you could do 0, for example, to allocate memory. And that was quite helpful.
Yeah, the problem with
But it's
doing relocating code under Zeptoforth is that Zeptoforth is a native code compiler. And when it compiles to native code, there is the BL instruction, which is a branch to it means branch and link, but it's pretty much branch to subroutine. And it takes an argument that is a relative distance from the BL instruction. So you moved your code, you would have to go through all the code and update all of the offsets for the BL instruction.
Sure. Yeah, the
I
code
see
must be
Atlee wants
relocated.
to talk.
I see. So how do you do the switching to compilation mode? Do you have some stacks or some counters or?
How I do it is that I make certain conditional and looping words smart. That is, they'll be executed both in compilation mode and interpretation mode. And what all the conditioning and looping routines do is they use something I call it the syntax stack. Where let's say if you do if, it'll push an if syntax onto the syntax stack, and all your subsequent looping and conditional words will either add to or remove from that stack. And then finally, once it encounters a then it'll see, hey, this if on this syntax stack is the only only thing left. So, and because I'm not within a word definition, because a word definition with a colon pushes a syntax onto the syntax stack. If I'm at an if and there's no colon syntax next thing onto the syntax stack, say, hey, it's now time to go and execute this code that's been compiled and then roll everything back.
That's great. What happens if you have some errors in the code that you type or that you compiled?
If there's an error, it will automatically roll back the changes made.
Yeah.
Like for instance, let's do begin. Okay, let's do unused. Just to show that would do begin foobar again. And foobar just doesn't exist right now. So we get this error, unable to parse foobar. And we do unused. And as you can see, it rolled it back because the dictionary free pointer is exactly the same. Or let's do something more detailed, just in case. Begin foobar. Okay. And let's do this again. And again, even though it compiled this before the word that it actually got caught on, the main task dictionary free is exactly the same afterwards, showing that it had rolled it back.
I see. Yeah, thank you. Atle, you had a question as well.
Yeah, no, it looks like you have a scope. So every time you add a word that increases the scope, you like push the indentation level in, and then you can push it in, and then it comes back out. That's what I was picturing in my head when I saw what you did. But I was wondering, so you start off a loop, and then you continue, you write something inside the loop, and then you finish the loop. But then what happens when you come back to the outer scope, the outermost scope? Are you starting a new nameless word, or what's happening to the old code? Does it get overwritten, or what happens?
Atlee, could you turn up the gain on your microphone, because I was having trouble hearing you?
Hold on. Is it better now?
Yep.
It's a bit better.
Yeah, it's better. Hold on. Just a moment. I'm having microphone troubles all the time. No, I was. Can you hear me well now?
A bit better.
I can increase it further.
Sure.
How about now?
Mhm.
It's probably fine.
That's all the way up. No, I was thinking of scopes when you started off this loop and then you wrote something inside the loop and then you finished the loop. And then I pictured like an indentation level, like in C, you increase indentation when you have a new scope. And then I could see a scope counter going up and down. I don't know if that's how you did it. It sounded different when you explained it. But anyway, so you start off this loop, right? And then you end the loop. And then you start something new. What happens to the old code? Is it still there? You can't reach it anymore.
The code that you compile within, let's say, a loop this way, it is not usable after you exit the loop. For instance, here's the example. Begin foobar, and then we're gonna just define a lambda here. And do H8. So that's the address of the lambda. But when we do here, H8, the here pointer is before the lambda that we defined. So subsequent compilation will overwrite this lambda. So basically anything you define in implicit compilation that's within the dictionaries for the main task has to be treated as being transient. It'll all be, it's not valid afterward. Did I get your question right?
Mhm. All right. So are there any further questions to Travis? Doesn't seem to be the case, so thank you very much again. I think this is
You're welcome.
inspiring, and it's probably a nice extension to have in many force systems. So yeah, not everyone has a syntax stack, so the implementation will probably be system dependent, but I think it's rather a nice extension to use control structures interactively and do this kind of implicit compilation. Right. So we proceed, I would say, to our next speaker, which is Jos-Ven. And he will talk about the things that he did with his robotic arm. Yeah.
Yes, indeed. I'd like to share my screen. Even kijken. Okay. I'm going to talk about building a robotic arm controlled by Ford. When I started this project, I had no experience with construction for such a thing, or no experience for the needed calculations. I took an optimistic attitude. After all impossible things are done one by one. And there is a lot of information on the internet about robotic arms and kinematics. Kinematics is the study of how to move objects. With forward kinematics is used to compute the position of an end effector, that is the gripper, when we know the degree value of each joint. with inverse kinematics that is used to compute the degree of each joint when we know the position of the anti-vector. And then I had two questions. The first one was where do I get it and how do I apply it? And therefore I built my first robotic arm, and that is a cardboard arm. The kinematics for this arm came in an Excel sheet from the Society Robots, and the sheet also works under LibreOffice calculation. It needed a small modification. At cell 65, there I had to negate the result of a calculation, and then I could indeed move the robot and check if the angles were right. Well, that was quite an encouragement for me, and I went on to build the second version for my robotic arm. And this version was controlled by Ford. It uses 3 SG90 servos. The construction was based on Thingiverse. And this arm uses an ESP32 for the Ford. It uses a power unit that is able to produce 5 volts and 3.3 volt at 2 amperes. It uses a breadboard to connect the ESP32 with the arm. And it also uses a 1 kilogram doorstop to stabilize the arm. The source for the kinematics in this case came from GitHub, and it was ported and adapted for this arm from C++ to Ford. And when I played with the arm, my conclusion was that the construction was unstable. The SG90 servos go sometimes way too fast, and the breadboard also causes problems. And that made me make the third version. The third version, and that's the version I still use bigger and slower servos. And that was absolutely needed because the old arm went all the way off my desktop. So I was very happy to be able to use bigger servos that are slower. Most important changes here. I now use a corner profile of aluminium. I use a turntable to stabilize construction. The gripper came from Thingiverse. I modified it a bit, and now it is smaller. It has bigger rounded grip surfaces with teeth and uses an arm of the SG90. That makes it easier to construct, of to use, sorry. The PLR pieces can now be used again in the bigger arm, and I added an extra capacitor to stabilize the ESP32. Even kijken. Well, let's see what we can do in CFORD now and how we can interact with the arm. At the right, you see the arm is a bit dark, but it's no problem. Oh. Okay, it is possible, the sources are still under construction, experimental, and still in the test phase. Let's see what we can do. The first, even kijken, we can move the arm by specifying an angle. There's a little bit of lag in the camera, so it's 2 seconds later. Besides using an angle, it's also possible to use set PWM duty, but that is not as clear as using the to angle, because it is impossible to know where the arm is at a certain point. Then it's possible to use predefined definitions. For instance, go to the home position. Then it goes back again. It's also possible, thanks to the kinematics calculations, to specify a coordinate, and then the robot of the arm, sorry, will move to that position. There it is. Then there is gripper control, such as open, close, and point the gripper down, so it is able to pick up pieces. Oh, sorry. You see, now it's down and it's possible to pick up a piece. Then there is speed control. Speed control uses timeouts and small adjustable steps. I will show it now to you. If it's not used, that is the most visual way to show it to you. I'm resetting the ESP32, and that means the robot arm and the ESP32 do not know where they are, and if they are not synchronized, sorry. And if I give the command to go to the home page, then that will be as fast as possible. That is not the way I would like to move the arm, because it's out of control. There's also another way to move the arm, and that is manually through a keyboard interpreter. Let's see how that works. The first action is that the arm goes to a down position, so it's easy to move the arm around. Now we can go forward, and of course backwards. And we can go right. Oh, sorry. And a file. Up, I took the, now it's going right. And we can go left. And of course the gripper down, open or close. And back to the home position. Besides this, it's also possible to execute a forward script for the arm. I prepared one, and the one we are going to execute is the pick and drop program. Even kijken. Okay, now the robot is going down and it's pointing to the point where it needs a little pylon. I'm putting the pylon on it, then it goes back. And now I can tell the robot to execute a test 2 times, and then it should work. That's the first time. Okay, that's nearly ready. And that's the last time. And it goes back to the home position. Okay. Then about the gripper. Even kijken. Oh, sorry. It's quite strong. If I open it and put the piece in it, even kijken, and close it. And now I can pull on it and you see the whole construction is moving and the gripper is still holding. And of course I can say open. Okay. Okay, to construct the robot, I needed several tools. For the hardware, I used a 3D printer to print the adapters, the turntable and the gripper. Digital calipers were used to measure the inside and outside the dimensions of small work pieces with high accuracy. A wire stripper AMPA30 was used to strip flat cables in one go and not one by one. A crimping tool with clicks was used for DuPont connectors. The clicks are important because they make it very easy to crimp the connectors. And in this case, I used an SN2549. A countersink bill was also used, and it must be one of metal because one of the screws must be sink into the aluminium strip. For software, I used FreeCAD 016 to make the PLA parts and export them to the STL files. Blender was sometimes used to correct the STL files where needed. And then the slicer converts the STL files for the 3D printer, and CFORD was used to control the arm. For FreeCAD, I only have minimal knowledge of it because the packet is quite big, and the same counts for Blender. I have only very limited use, and I am only able to correct these STL files. Well, that was actually my presentation about the ARM. I will give you the links in. Even kijken. The links in the. Oh. Sorry. Oh. Gaat niet goed. Oh, even kijken, dat kan niet. Oh. Ah, sorry, I'm stop keys. I think I'm have troubles with Zoom.
Mm-hmm.
Even kijken hoor.
I just stop your sharing and then
yes, please.
you can deal with it.
Okay, that's thank you.
Mm-hmm.
And now I can post them. I think chat, yes, and then okay. There
It's
are the
always
links.
when you do the presentation, it always changes its user interface, which is very annoying.
Yeah, indeed. Even kijken, there are the links if you want to know more about the stuff I presented. My question now is if there are questions of if you have links for me. tips for me, sorry.
Well, thank you very much. So I think that is really amazing. So the robot that we saw, you built it really from scratch. So
Yes.
that's, wow, that is, it's amazing. How long have you been working on that?
Now since January.
Wow, wow, that is really fast. That is really fast and amazing. And also what we saw, the interactive way to move to positions and so and then having the arm controlled. Do you have something like waypoints where you say, we call it, I reached a certain position and now capture that position so I can go back later? Maybe you can just use variables to do that and or constants to capture a position where the arm is, and then you teach in the movements, and then you can repeat them afterwards.
Yes, there is a capture utility, alleen, sorry, there's a
Yeah.
capture utility, but it takes time to get there and to operate it. But the program I demonstrated was made by that capture.
I see. I
And
see.
that program is only four statements big.
Okay. Yeah, very nice. So it really very well shows the advantage that you have using force there. So great. I like this. Atle, you raise your hand. Please go ahead.
Yeah, I was really impressed. And the accuracy, I love the accuracy of it with those servos, because I've been fiddling with robot arms myself, and it's been wobbly and it's been inaccurate. But you said something, because to get that smooth movement, I tried to go from one PWM value to the next PWM value in small increments, and make those increments larger to increase the speed, and then to slow it down when it approached the goal. But it was still going in a jerky motion. But you said something about timeouts. Am I correct in assuming that you found a better solution to that?
Now, the speed control is a bit tricky. I actually use two speeds. One speed to move, now let's say a bit quick. And the last 10 degrees, I tell the robot arm, slow down. And that's all actually. And because of the mass of the arm, it tends to it wants to go faster, but I tell it to go slower, and then there is an interaction between those two speeds, and that slows down the arm.
Mm-hmm.
But how can you control the speed? It's a closed loop system where you just send a PWM value to the servo. How can you control the speed at which it moves?
Oh, yeah. The kinematics translates the needed. It makes a translation for the needed angles, and the angles is a kind of do loop, and that knows when the last 8 degrees are arriving.
Is this in the servo, or is it in the source code?
Sorry?
Is that control in the servo itself, or is it?
No. In the source code of Ford.
That's really cool. That's really cool.
Mm-hmm.
Brilliant.
Great. So are there any further questions to Jos?
I was curious about the corrections you were making using Blender. Can you talk a little bit more about why you needed to use Blender to do some updates to the STL files?
Yeah. When you make an export from FreeCAD, it usually is all right. But when your model is complicated, then it tends to make manifolds in the STL files. And manifolds that are small openings in the model are not allowed in the STL file for the 3D printer. And under Blender, I can correct these manifolds and other errors. In fact, I can tell in Blender van recalculate the whole model.
It's interesting that you use different tools. You know, one would expect Blender to be in a completely different domain. So it's interesting that Blender solved an issue for you there.
Yes, it is.
Thanks. That's awesome.
Okay, thank you.
Sure. So, additional questions? Christian, you're so silent today. Anyway, great. I would say that we go into a break. Let me share my screen for that. And here we go. A small coffee break, whatever, if coffee is appropriate at this time of the day at your side. Something like 10 minutes or so, and then we will meet afterwards. And Julian had some internet issue earlier, so maybe we can see if that recovered. But we saw also something during the test. So right. So I would say now it's like 20 minutes past the hour. Let's meet at past again. And so the conference is open, so everyone can start chatting, but we will continue with the talks in like 13 minutes then. Okay, if everything's fine, everyone's fine with that. Good. So.
So, waiting for the break to end. Nobody wants to chat.
Give me a minute until I have more coffee in my bloodstream.
Oh yeah. Okay.
Be right back.
Mm. So yeah, last meeting of 2 months ago. How to do it? What I have. No. And we're in Fort. Mm. Mm. No. Mm. So I think the coffee break is over, isn't it?
Uh,
I think so.
yeah, coffee break is over when the moderator's coffee break is over, or rather the conference owners.
Yeah,
And that would be Ulrich.
yeah. Well,
So no rush.
no rush, no. Mm.
God gave humankind the concept of time. He did not say anything about a perpetual hurry.
No.
Maybe we just made up the perpetual hurry ourselves. Yeah.
Management probably did.
Mm.
Ah, yes, good point, good point.
Hi, Ulrich.
Hello.
So I think next we've got Julian. I think Julian said he was okay for the talk. So that's a talk on PC4. Are you ready, Julian?
Yeah, here I am. Can everybody hear me?
Yeah, great.
Yeah, yeah.
Okay, let me share my screen and window visitor it. Can you see my screen?
It's refreshing. It's refreshing.
Is it visible now?
Yeah, well, it says
No.
you started screen sharing, but we actually don't see the screen.
That is exactly what I mentioned earlier, that it sometimes doesn't work on Linux.
Okay, let me try again. Okay, share screen. Let me try sharing the whole screen. Can you see it?
Still not.
No screen, okay.
Julian Roker has started screen sharing, but the content doesn't make it.
Still nothing. Okay, let me just refresh the page and see if that changed things.
The display says double click to enter full screen mode. Double click to enter full screen mode.
That's probably for us.
Yeah, I think so. If it's not showing it at all.
Okay, let me try again.
Then
And now?
Yeah.
Yes, yes,
Yes.
there it is.
Okay.
What did you do? What did you change?
nice.
I just refreshed the page.
Okay.
Okay, so, well, this time I want to talk about some of the more complex behaviors along time in programming. So when you're making stuff like games or something, you need to have, or you need to track multiple entities as time goes by, or have those entities change. So that introduces a lot of problems, such as allocating things, the communication between things, keeping the time so everybody goes at the same pace, and as well as the allocation, making sure there's no memory leaking. So I tried and came up with an alternative to multitasking. It's not quite multitasking because you are not changing the context, or you're not switching registers, or making a window of memory. Is just the same program, but it's jumping around as if you would call a program normally. However, this has the tasks have memory allocated to them, and as you go jumping around, they all act as if they were separate processes. So you have 64 bytes or 16 words of user memory. And then this memory is split in the active word, which says if the task is active, 2 words for the timer, the previous time and the difference, the delta time, and as well as the address of what will you call when you enter this task. After that, you have 12 words of user storage. And this makes it really easy to make the spawning of other tasks. You can do precise waiting, although I'm using milliseconds, but the timer resolution is microseconds. You can use to make incremental movement as like you would in games, as well as state machines. So now I want to show you a little implementation. This is a little bit larger than what I have because I am commenting it all around. So we first start with the red word here, Tmax, which has 127 total tasks allocated. Then we start allocating the memory for those tasks, and you just multiply it by 64, that 127, and then you zero those tasks using this number fill routine I have here. Then to access the current task, you make a new word, call it ctask, and ctask at the first word that word has is a number. That means here in PC32 I can use it as a variable. So I can make ctask change itself or another word can change this one here, incrementing the C task number. Now, okay, you want a new task. So you get the maximum task and you start a loop to see which task is free. So the task that doesn't have the first word in the memory space doesn't have a 1 or it has a negative number. So if that task is 0, you drop the loop and you subtract the maximum task number, and you get an address of the task. So if the loop completes, that means there's no task available, and you say tasks full as a string, and you jump into the error routine, so that will stop compilation at that moment. Then now, how do we access the user storage? Right, so the user storage is, we have the ctask word that will give you the current task you are in. So if you are in whatever task you made, you can always call that word and it will say, oh, you're this task. Okay, so I know which task I am, then the rest is just getting the memory. So I have the word here, tdata, which just shifts the number of the slot I want and adds it to the current task, and td_add, which you'll just read the data. Now the next most important part will be the timing. So we have TMS, which will give you the delta time of that task. So how long has this task been running? You can also change the delta time. So for example, the task executes something and you want the task to execute it again after a certain amount of time. You go ahead and you zero your delta time, and that's how you get timing loops. Okay, so next is the most important word, I think, is the yield word, which will increase the C task here. So you can see one C task as a reference, and U plus store V, which will increase the number, this one here, it will be increased. So you increase the current task and you check if it's valid. So if it's valid, you increase the delta time and you fetch the function and you jump to that function as if to call the task. If the task is not valid, then you just go ahead and jump to yield once more and just keep repeating, keep iterating the tasks. Finally, after you're done with the task, you can call inside the word that calls inside the task itself, you can call tdone, and that will zero out the first user storage of the task, and that will simply skip it and mark it as a free task to fill with another one if you spawn one again. Okay, so finally you need to create the actual tasks. So first we have up here in task, you will call end task, so new task here, and it will fall through to the next word. We will just be task store, which you will be storing the task, the time, and you will also be storing 4 user variables, just to have something to kick off the task at hand. You can also do the plus task, and you can also do for task, which will here in task store, it will store just initialize the task. Here in for task, it will actually store the user variables, the first or the second 4 user variables you want to use. And finally, here is twait, which is I think the most important part. Here you will get the timing, And if the timing is less, you will simply yield. If the timing is greater, you will drop the function call, so you don't start wasting timing. No, you don't start wasting return stack slots. So you will drop that call and you will just yield once again. So finally, you have the usage of the tasks. So tasks are coded as normal definitions with the word yield compiled as a jump. So you compile it as a in the golden color or yellow. If I don't know if you can distinguish the two colors. So in order to start the tasking, you just have to call a word that has yield inside it and that has been added to the task task pile or task stack. So now here we have a little example. It's called a horse race. And here, up here in this comment here, I have slot number 4 as X, slot number 5 as Y position, slot number 6 as character, although this time I'm printing a string. I forgot to change that. Slot number 7 will be the rate of advance of the horse. And slot number 8 will be the wait time. So down here, we have 3 horses, Honey, Bagel, and Lester the horse. And each horse has, if we read it in the reverse, the comment in the reverse, you have an X position, a Y position, the character, or in this time, the name, and the 7R, which will be the rate. So I'm calling for task to include those four parameters as a task initialization, and the task itself, which will be used for all 3 horses, is this t.horse, which you can up here see. You fetch the x, you fetch the y, you convert them both to integer values, so IV. That's just because these numbers down here, these are fixed point values. So in order to put them on the screen, you need to convert them back to integers. And you set the position of the raster on the screen. Then after you set the position of the raster, you print the string. And if you have to wait, you wait using the t wait here, as you can see. Then you increase the y position using a random number. Again, the random number is a fixed point. I ended with 123, so it's in the range of 0 to 1.0 positive. And you add that to the position y, multiplied by the rate, which is the slot number 7. So now here, Lester the horse has he's a very slow horse, so he has some time getting started. So I want Lester to wait 650 milliseconds before starting to run. But in exchange, Lester will run at 1.2 point the speed of the other horses, which run at 1.0. So that's the base speed. They all start in the same position y at 80, and they are all spaced around. Okay, so I call for task, and for task leaves you the task on the stack. So I add, I want to set the 8th position of the user storage. So I get 8, shifted, multiplied by 4, added to that, and finally store the waiting time. So I have other tasks here. The task that sets the frame, which is just checks if we have to exit the program, clears the screen, sets the color, and then yields. And finally, the tasks that will display the screen. it will display the winning line here in color number 6, which is the blue color of the blue words here. And then you will display a rectangle and finally display and then yield. So as I said before, if you call t.frame, that will kickstart the example. So let me press F5, and you can see that Lester waits for a second and starts running, and let's see who wins. And you can see that Bagel the horse won. So if I press escape and run it once again, let's see if Lester wins this time. And seems it doesn't want to win, and it still doesn't win. So that's it pretty much for my presentation. Lester didn't win, but he won a lot when I was writing this. So thank you for watching. My site is dscf.co.uk, and you can check my YouTube at New Tech Studio 9236. I make tutorials every now and then. I'm trying to document how to make things in PC32. So thank you very much.
Thank you very much. Has anybody got any questions?
Let me unshare. Stop sharing. Okay.
Julian, I have a
Oh,
question.
hi,
You can add a task when the program is running.
yeah, sure. That's the whole point. You can free tasks, and the task itself can spawn other tasks. So the tasks they can let's say you wanted to have like an explosion, and the explosion will create bits of
Okay.
rubble or something. They can be spawned. And if you want some interactivity, you can make the command line a task itself. So while the yield loop is running, you can add other tasks using the command line.
Okay. You have a unique array of tasks, and
Yes.
you can put the task, and always the computer traverse this array and execute when need.
Yes, and unless you fill the task space completely, this is pretty rock solid. And I think it's pretty easy to implement even in other ports. It should be really, really small, like 12 lines or something, like maybe 20.
What happens when you have an error in a runtime with one task, and it's easy to see or to detect when you have a problem?
Yeah, you can do it. I didn't really do much error management, but if you can, if the task itself can print stuff to the screen.
Okay.
So it's not like an automatic debugging. You still have to do work, but it's really easy. It's not that complicated.
You log the task, and then you search the error with the login screen. And
Yeah,
I think
if the task had an error, it could write I couldn't find this to a memory that has the same offset as the task, and you could look that up. I just didn't implement too much error other than, oh, the tasks are full, you can do that. But because I don't really have much error, too many errors pop. So there's that.
okay, thank you.
Thank you.
Anybody else got questions for Julian?
Okay.
Thank you for that fantastic presentation.
Thank you.
So, thank you. So,
Yeah, that was terrific. Very interesting to see some colorful stuff.
Next up, we've got Pablo, and you're doing
Yes.
spatial hashing in fourth.
Here. See the screen?
Yeah.
Well, I'm slowly developing a physics engine for the language, and a key part of the physics engine is the search of the neighborhood of an object. I show an example. I don't know is see the animation or I have high latency, but this is a basic physics engine with colliding balls. And the question here is you need to detect every collision in this object and search for the collision. You need traverse the square of the quantity of this object, and then slow very fast this program, and then I need a structure for speed up this situation. Well, I searched in the web. I found this guy, Matthias Müller. We have a very good information about this subject. I use the documentation he write about spatial hashing. Here is the PDF, and show the problem. The problem is get the particles, the collision between particles, and say, well, the naive solution is very costly. And then he say one of the basic structure for accelerate this question is make a grid and check only the neighborhood of the grid of an object, and then you need a store in the grid. And the first solution for storing a grid is make an array for grid and make a linked list of the object in every cell of the grid. And then this is not safe for this guy, but he tried to avoid this representation because I think it's reasonable. If you have a linked list, you need the double of memory for storing any array. Because you need storing the number and the pointer to the next. And then make a dense grid representation using a trick of storing the index of the list of particles and use the current cell and the next for search for obtain this object. Of course, if of course is use a hash. You don't need represent the entire grid. only a fraction, then you have collision and need resolve the collision for a hashing array. Well, then he explained how make this structure, how calculate this number, and implement in an example in JavaScript. And the two core functions are create the array, the hash array, with trees with these 3, 4. These 3, 4 are the description of the algorithm saying here. Count the quantity of objects in every cell, do the partial sum, and fill with the number he needs. And then, well, I say, I implement it in Ford for see how work and make the same algorithm with Ford. And it's very similar. Here is the 3 loop 4, where are the same. Is different in the reference of memory because of 4, but it's the same. You can see this 4 is this, the initialization of the number of the object, and then the add the number in every cell of the hash, and the calculus of the number of the object. This is build the hash, and this is the JavaScript version. And the other function, important function, is carry for a neighborhood. This is the JavaScript version, and this is the Ford version. I do a simple program, write particles in the screen, and check the neighborhood of the mouse position, and draw the balls in near the mouse. Then this is the example when where I have the mouse. You see the rectangle, the white rectangles. Is the execution of the work for querying the neighborhood. This is the same implementation of Matthias Müller, this guy. And then, like a Ford programmer, always ask, can be more simple, and then thinking about the document of Matthias Müller, I think, well, perhaps I can use the original and no need count the max the quantity object and do this tricky for obtain the correct object, because first the number of objects is always the consecutive numbers, and perhaps the position of the number, call it, o sea, I don't need a pointer to the next because the position is the number of objects. I have well, this is the first part. And then I try to make this representation and this idea come to me. Well, this is the idea. I have the two array, the grid, the representation of grid, and an array of a number of objects. And when I insert an object 1, the space in the is a mark for a no object. Can be -1 or 0 or depend of my implementation. I use in my implementation -1, but in this graphic no. Then I insert a 1, and the algorithm is copy first the previous value of the grid in the object 1 and fill the grid with the number of the object in this space. When add the object do the same. The object do here is separate and then store in the grid in the correct place, and the third object do the same. When I have a collision, I store in the corresponding cell the number, but first copy the previous number of objects in the array of the number of the object. Then I can reconstruct the list. These two objects are the object 4 and the object 2. And the object 2 have a end of list, and then only the list 2, 4 are the object in this place. Object 5 do the same. In 5 store the 1, the previous one here. Then the list are 5, 1 in one end of list. Then I have the two objects. And third object, for example, 6, in the same place of 4, copy the 4 in the place of 6, put the 6 here, and for reconstruct the list, I do 6, 4, in 4 is 2, yeah, and in 2 is end on list. And no need pointer. The pointer and the number of objects are similar. Then this is the implementation of this idea. Now build the array is converted from this, the tree loop looping with the object in one loop. And the loop only copy the two numbers in this explanation. Only make copy this number here and copy this number here. Artists take the number of the matrix and store in the mat list and copy in the matrix the number of the object. And the carry is the same. I show. Then this build the matrix is converted to this, only to this. And because you no need know the quantity of object, because you make a loop, one loop only, and you need acá make 3 loops with the number of objects. You need n draw or know how many objects used in this representation, and here not, and I can do in the same time with drawing the object. For example, in this case, here is when you update the position with the velocity, and I can remove this function and make the construction of the structure in this place. But for the example, I make the same structure for compare. Then I translate this in very simple version. I not take the time, but I like to see is more simple, and then I prefer this representation. And the query is a more simple too, because this is the traverse of the change of the chain of number of objects, and here I need to take the interval and count the quantity of objects, and then it's a little more simple. Well, then this is the original version, and this is the new version with a more simple algorithm. I don't know if you see the rectangle. I can fill the rectangle, change the code here, library SDL, fill. ¿Cuál modifique? Este. Here. Well, it's only this. Thanks. Any question?
So what you're doing is using the index to the number index to fetch the next item as if it were a linked list, but you don't use.
Yes.
Second. That's pretty cool. It's almost like a sorting algorithm, right? So like the was it? I think it was the bucket sort, but it's not. I don't really know much about sorting, but that's pretty cool, that idea. So aside from that, the graphics didn't look too fast, or I don't know if it's my internet, but is it faster than the original implementation, or is it about the same but less code?
I don't see if the algorithm is fast. Because I don't see. I need to make a demo with much more option. But in the first demonstration with no acceleration structure, if you add too many objects, you see in the computer how the calculus is start to slow.
Yeah, in the one with the lots of balls, right?
How?
The one with the that had the entire screen covered, right?
I don't understand, Julian. Sorry.
Because this demo, the one you're showing right now is the one where the walls are falling and colliding, right? And the
Yes.
previous one that had the filled rectangle is the one that makes the program go really hard.
In this now is a slow down. It's a slow down, and I collapse because not have space. But you note the slowdown, and theoretically with the new structure I can handle more objects and not slow down in the calculus of collision.
Oh, that's pretty cool. I really like the idea of doing away with the linked list.
Yes, I don't know why not use this simplification. Really, I don't know. I only search for a basic structure for optimization, and then I found this organization for make a more simple version. I don't know if it's novel, is original, or I simple coding and see he work.
Oh, okay. No, I think it's used in sorting, but I think it's pretty good.
I don't no need sort in this structure. Eh? It's hashing.
Yeah. Oh, okay.
Do you also have plans for a 3D situation?
Again, sorry?
Do you also have a plan to make it working in a 3D environment?
If I understand well, is two dimension? I plan to
3. Can you do you have a plan to transform it into 3 dimensions?
Yes.
Okay.
Sure, this year I'm making a 3D environment, and I need this this structure for make the collision, because it's too slow if you not have this class of structure.
Yeah, Blue. I take it when a ball moves between cells, I didn't quite get. I take it you have to delete the entry and insert it into the next grid position. If it as a ball moves.
I try to understand.
Yeah.
You ask about how reconstruct the structure when the particles move.
Yeah.
Every frame, I build the structure again.
Yeah.
But
okay.
It's not very costly.
Okay.
It's linear.
Okay.
If I compare, it's quadratical.
Yeah.
And this structure is linear.
Yeah. So it's not even worth trying to modify the list. You just rebuild the
exactly.
list. Okay.
Rebuild all.
Okay.
And the new version, the simple version, have more room for optimization, because it's in one you don't have 3 loop, you have 1, and you can put this loop in the drawing of the object, for example, and this disappear. the loop disappear because está is in the drawing the wall, calc and fill the structure.
Yeah. Do you think it could be parallelized? If you have, 4 or 8 processors, can you build individual grid areas independently?
You for parallelize, you asking, you need a coherence in the reference. I don't know how make the reference. You need no lost the reference of every object, but every object is a position in the array. The key part of this algorithm is I use the position of the array like a number of the same object, and then I don't need the pointer.
Any other questions? Okay. So thank you, Pablo. That was excellent. Brilliant.
Thank you.
That was great.
Thank you.
Thanks.
I think next up we have Peter. I did see, I think, oh yes, there you are, Peter. You've moved on the screen. How are you, Peter?
Yeah, good. So like it's early in the morning rather than late at night, so it makes a little bit of difference, and I can have a cuppa or a coffee and wake up a little bit. So that's good. How are you guys? Good.
Yeah.
Yeah, like the later time, it suits me better, but yeah. So anyway, so sorry, Rob.
No, yeah, I was just going to say that you were talking about, I think, Tachyon and RISC-V maybe, and you've been doing some interesting things. So we'd like to see that. Thank you, Peter.
All right, thank you. So, yeah, guys, I've just been ordering all these RISC-V chips from WCH, a Chinese company they're famous for, or infamous maybe. It's for that 10-cent RISC-V chip, that little 8-pin chip that's you can't even see, because even if I stuck it up on the end of my fingernail, you wouldn't see it. And I've just lost it. So, but we can throw around RISC-V chips. It's not a problem now. But the thing is that what I want to do is to build a fourth into that chip, so that I can just talk to it and program it up for simple tasks and perhaps even more complicated tasks, and also extend that RISC-V concept to the larger chips that are available there. I might share my screen here so that we can share screen. I'll share hopefully the correct screen. I've got a few different ones here. All right, I want to make sure that it's got the right one. Desktop 2. Here we go. I think that's the one. Looks good. And okay, you guys can see that now. Okay, screen share there.
Yep.
Good. All right. So over here we've got the. I'll just move my zoom around. Now over here you can see this part here. We've got the CH32V003, and this is available in the tiny little mentions down here. SAP 8 package, the 16-pin package, and of course the TSOP 20 and QFN 20. So I decided to prototype with the 8-pin one, because I want to see what I can do in the smallest type of package, because traditionally I've used little tiny microchip PIC chips in 8-pin package, having to program them in assembler, and it's just awkward, and I hate programming in assembler and those things. And I like to be able to get these chips. They run on 5 volts as well, and just have them pre-programmed with Tachyon 4th, and that way I can either load an application in just by typing in a few lines of code, or I can even use them as a scripting engine. So from another processor, I can send commands through to it and get it to execute immediately, etc. Now, this particular processor here, I've got a little board for it. I'll just show you that one there too. You can see over here, I've got the, hopefully I can bring that up a little bit more. I don't know. There it goes. Doesn't want to go too large. Okay. So I've got a little eval board for that there, and that one there has a little the little TSSO P20 pack on there, and I need a little programming dongle for it, which I happen to have now. I've only just received it last few days, but been a very busy week, so I'm still doing this work here at the moment. But in the meantime, I also have the larger cousin of that one, the 307, I think it is, this chip over here. And as you can see, it even has Ethernet and a PHY built in as well, the direct connection up to the mag jack, etc. So interesting thing about these chips too, the larger ones are the USB facilities. When we look back here at the block diagram for the 307, we see it has a USB 2.0 high speed and full speed device on there. We can use this for lots of things. They even have much smaller chips that have this built in as well. So what I like to see is RISC-V Tachyon 4th running on this and having USB serial. Same concept, by the way, guys, extends to the ESP32 C3, C6. I really don't want to see that one going as well. But I figured I'd start with a small, simple chip. I go back to the 003 and I think, well, 16K flash, 2K RAM. This is taking me right back down to the 80s, but we can fit a 4th in there. And on the P2, Parallax P2 processor, which I developed a board for, and the Tacos, which is the Tachyon 4th, that was in 12K of that silicon ROM of that chip. And in there also have all the SD card drivers, some FAT32 support, etc. I can fit that in 12K. I can fit it in 12K on a RISC-V, especially with a compressed instruction set. It has this happens to be I found out an RB32C EC, and the E means it doesn't have 32 registers, only has 16. I don't know why that is, but that's okay. We can deal with that. And the C, it handles compressed instructions as well, so 16-bit. Although on the P2 processor, I only ever used, it only has 32-bit type instructions, so I can't see a problem with doing it that way either. And so this should be pretty good working like this. And as you can see, this particular processor, the small one, runs at 48 megahertz. That's fine for simple things that we can use them for. But it also has a lot of peripherals built in, even into the small unit. We have the USART, the I2C, the SPI bus, and lots of other little things in there, little goodies to play with. I think I ended up paying about 25 cents or something like that for the ones that I received. I've just bought them in little 50 lots, just off AliExpress. They came through pretty fast, along with all the other evaluation boards that you can see there. And now the 4th itself, I might bring this across here, over here. You can see that on the screen. And essentially it's a 4th where I have the inner address interpreter interpreting not just addresses, but also certain ranges as tokens. So what happens is, if you can see this all right, I might increase the screen the size of that, drop this back. So you can see in here, this is the main do next loop of the interpreter. We call it an interpreter, don't we, at that level? We're loading unsigned, the high unsigned, loading. I'm trying to remember all these mnemonics here too, but I'm loading 16 bits up here. This is step 1. As I mentioned up here, I'll increase that here, and I load up 16 bits up into XX, which is one of the registers I've just named. Point to the next instruction. So So we're 2 bytes, so it's one word. And then I'll just do one extra check before I decide to execute this as assembler. Most of the time, all the primitives are all assembler, so we don't have any code field address. It's this, you just run it as it is. And so it'll say, well, okay, it's an assembler one. If it is less than this particular address, it will simply go up to here and call that assembly code directly. So we jump and link this register, etc., to that, run it. And then when it's finished, it comes back. And so it's a fairly tight loop here, 4 instructions. It's a pity we didn't have any auto increment instructions, but that's all right. And that will execute very, very quickly. Now, all the primitives, of course, are in assembly, but once we want to execute threaded code, well, there's another part there that this is unfinished here at the moment, but another part there that will compare it against a constant that's stored in a register. I'm using registers for a few constants here. It says, just to make it nice and fast. And then it just checks to see that, well, if it's above that, greater than or equal to it, it will treat that as if it's threaded code. So we don't have a code field address that says enter. It just simply says, I'm going to go through a threaded address list. And it goes through to the enter part. There's another part called decode in between these two, which says it's a literal. You know, I can combine, put 10-bit literals in there, negative numbers, etc. If, yeah, etc. All the conditionals, just in those particular tokens. That works really well in Tachyon. Everything's very compact, and it works really well. So I like the concept. And we'll see that happening in RISC-V as well. And that includes the ESP32. And probably what will happen there with the ESP32, very interesting, it's got lots of RAM. And Tachyon really works well when it can run out of RAM and everything is in RAM. It doesn't need to worry about going outside of a 64K page. It can handle it really well there. So I just, that's where I'm at the moment. Look, and some guy on the web wrote a flat assembler, and I want a flat assembler. I just want to be able to see every instruction, have it exactly the way I want it to work. And he's written that, and he also wrote a fourth. It's called Des fourth or something like that. I have hardly had a look at it, but I grabbed it very quickly. And he's written one that doesn't really fit in this chip, but that's okay. I'm using it just as a little compilation example. And Des fourth, it's called, this one here. And I've chopped down some of the stacks. He has, you know, I don't know why the data stack's so huge. You know, he had stuff that was really huge, etc., and was taking up 16K of RAM. So I'm just going to use that as a quick little test for this chip, see if it works, and then use that assembler hopefully to build up the kernel. And because it's quite awkward to define the high-level words in here, because high-level words we see over here, for instance, here we go. Here's where we use, okay, this is it. I think that's it. I'm trying to find out where they are, yeah. But anyway, they use all kinds of offsets and everything else in their RAM base addresses, etc. And it's rather awkward looking. So I thought, well, I'm just going to get the basics of Tachyon in there and use it to compile itself. So at the high level, keep everything nice and simple, a bit like an E4 in a way, but so we can just extend it as required. So that's basically where I'm at the moment. I did manage to put MeCrisp up onto the 307 since it had an image for the 203, and it seems to work quite fine. I'll bring it across here. Over here, this is talking to MeCrisp on the 307, And there we are. I'll increase that screen size up a little bit here. That helps. Not sure how's it going. Okay, there we go. And reset again. All right, so this particular MeCrisp version is running on the 307, even though it's written for a 203, and it seems to be compatible. The 307 does have floating point though. It has a lot of extras in there as well, and so I've been using this as a little exploratory tool just to check out the peripherals and everything else for that. And I could possibly write my tachyon on top of this, using this as the way to get it into memory and to test it all out. But I decided I'd go back to that simple assembler approach, try it out on the small chip first, get that going from the ground up. Haven't had time to finish it, as I mentioned, but it's looking good. This particular one is only running at 8 megahertz. I wrote some extra words for it and saw that, oh no, it's really just, it hasn't even used anything much in here. It hasn't tried to set up any of the peripherals in such a way. And I think that particular chip runs at 144 megahertz. So it would be quite speedy. And but that'll be later on. I really want to get this tachyon into 12K of flash on board the chip. And of course, tachyon compiles each word as it comes in, compiles. It doesn't even have a text input buffer, grabs a word, compiles it. So on a command line, we can hit the enter and it will execute that and release that code space again. So that will be very handy if I happen to have this slaved off a bus, and I'm going to build in that bus software as well, which is a particular version that I use, nice and simple. I can chat to that chip from a master chip anywhere, could be anything, and I can have lots of these little 10-cent micros scattered around. I could talk to that one over there and have it program and up, test it out, and then release it, and the main processor chip can go around using them as little peripherals. So I think it'll be very handy. Haven't done too much, but any questions?
This all runs in pure RAM, right?
Normally Tachyon does run in RAM on the P2 and the propeller chips, but in this one here, it will be running in flash. And then of course there's another area which has the RAM, so very little in RAM. It only has 2K of RAM. I want to maximize that for being able to use most of that for code storage, so that I can just flash it. I test it out, then flash it as required.
Oh, okay.
Yeah, so we can see when with the larger versions, ESP32, 400K RAM, no problem. Everything will run out of RAM, and so that'll be very powerful. Yeah.
So Peter, what is your intention if you want to do applications? So I understand you have an interactive force system, and then you can do definitions. But if power goes away, then you have to reload it.
Yes, if you just want to, you can run it like that. It's a secure system. Anything you load in then disappears, and that's fine. It'll be from the main processor, but I can flash it in. Of course, I've got I'll have at least 4K of flash available, maybe even more, and I can say, okay, I want to lock this in. This is a great little application for an 8 or 16 pin or whatever chip, and it works very nicely. Flash that, and I want to make it in such a way that I don't have to flash it beforehand, because it's always a nuisance during development, and just simply have it in RAM, say this is good, back it up, and once it's backed up like that, then it's locked into the chip. But the important thing is I don't need to have all the programming tools. I can just have these pre-programmed.
Yeah, so the chip can flash itself. So you don't need the programmer once you have an interactive force system in it with the flash routines in it.
Yeah, exactly.
Ah,
So I'll just have
great.
A little test socket, and I'll probably just do lots of them. And it'd be nice if the factory would pre-program these. Why leave them blank? Put something useful into it.
Yeah.
I got that into the P2, didn't I? The P2 chip could have been blank, and they had 2K that they used for serial loader and flash loader, and there was 14K left over. Somebody else wanted 2K to do their SD type boot stuff. I already had SD in there, but I managed to get it in there, and so it's great. It's locked into silicon. You can't just change it easy because it's not just a mask. But if on these little chips here that we see here, especially the little 8-pin chip, and all the little ones like this, if it's preloaded, who knows? Wouldn't that be fantastic? Just order chips, and you don't need a programmer. Just put in your circuit, start talking to it. Really good. And I mentioned the bus protocol where we can multi-drop them off a single wire or 485, and I've used that in my Tachyon 4th. I've done some demonstrations of that before. Basically, it's a ping pong protocol, implements full duplex over half duplex line, and that means that I can talk to it as if I'm connected directly to the serial console on that particular chip, and yet at runtime it can just be used as a local network.
Yeah, well, that puts it ahead of the existing development tools where you have to compile on the PC and then use the programmer to flash the entire chip. And as you say, now we can build networks where you can interactively program parts of the system and update this. And we see how important this is with the Voyager probe, and being able to reprogram a system. Yeah, great.
And any other questions? Just still early days, so you can put your little ideas in there too, and maybe I'll implement them.
Peter,
yep. Right.
Do you happen to know how much flash was taken when you put ME Crisp onto your 307?
Oh, I didn't check. In fact, I mean, when we look at it here, and I will try to shrink that screen down a little bit, see if that works. Here in X. Okay, that doesn't tell me anything. Of course, the actual flash part of it is in 0. I do have a dump facility. If I have to put anything in here, it's a real painful exercise. My dump. I should put in the flash, but the thing is it apparently it takes up a lot of room because it tries to optimize and generate for something that would take 8 bytes of code. I've looked at it, and it will take up 40, 50 bytes of code instead, because it tries to generate machine code for everything. And as we know, the real speed is at the primitive level, not at the high level. So we don't gain anything by having assembler for instead of threaded code.
Thanks.
I think you're familiar with this. For instance, Tachyon, I saw that most of the time it was caught up at the low level, and so I implemented instructions for that, SPI instructions, SD things, etc. And so at the high level, it's still running fast, and then you have all the bit bashing and all the other things, etc. And they're implemented in assembler primitives. And the whole concept was, the idea was that in the past, I'd written fourths that had a lot of assembler in it. I'd look back through the code, and I'd have source code with lots of assembler. I said, no, look, want to just program in forth and to look at what's required to make it run fast, I don't have to code certain things. And so I wrote Tachyon in such a way that I could do that. I could just stick to high level forth. Very, very rarely will I have a code definition in there, assembly definition in my source code at the application level.
Very good.
Yeah, so I can't tell you, I think right at the moment what MeCrisp is doing. I could load in my dump utility, etc. in there. If you want, I can just do that right now. In fact, I think I've got it up here. I've got a dump in here, but then I have to slow down. You know, MeCrisp is really, really slow. I tried a new line delay. Here we go. How about we go? The character delays. We'll see if this works. I'll see if that works. Normally gets lots of errors if I try to go too fast. Yeah. But Tachyon, I can go up to, even on the small chips, I can go up to mega baud rates and in hundreds, of milliseconds, fully compiled. So over here we can go 0, 100, dump. And there we go. And it didn't like me because not quite sure why it didn't like me just then. But in the RAM area, it's 2000 upwards. I'll dump them as, no, it didn't like that either. 200, dump as longs, dump long. You know what? I don't think I've got this in here properly. I don't think it's compiled correctly. So one of the things I do with Tachyon is have the block load mode, well, not block, but so it has a header in the source code file that says Tachyon, and so it goes into the mode where it will only echo back errors and or little things, etc. And report at the end how it went. So that way we can, normally when you paste in source code, you can't follow it. It just goes through there, and you can't see where the errors were. That's probably what's happened there. I think by the look of it, because I can't see down here. Some of the words are down there that should be working, but obviously it's not. So I'd have to go slow again. I can do that all again, and say to it, even slow down. This is really slow. This is terribly slow. It should never happen with this. Happened back in the very early 80s, I think, with Forth, but here we are, decades later, and really, really slow.
Well,
one of the tricks. Sorry. Yes.
Question. Yeah, I saw that. Well, this is MeCrisp, but also in Tachyon. I saw that the full names of the words are stored. Do you intend somehow to shorten the names because of the limited memory space, like this was in very early POS systems, only 3 letters plus count? Do you think it's reasonable, or do you just say, well, if the application is too large, then just pick a larger chip?
Okay, so for instance, okay, here's Tachyon on the P2. It's called Tycos. In the ROM, and if I just disable, I'll pull out the SD card, and I'll go. So this is the reloaded version in RAM. It's a full version, so I'll get rid of that, and I will go back up disable. That way, I can just get back into the. All right, so if I reboot. It is now in the ROM part of it. So auto board, I'll put in a special sequence here, go into it, and there it is. This is my original version I wrote back in 2019. And these are the words in here, just to show you what's in 12K. As you can see, they're all full words. It sometimes is more trouble to go and shorten them and handle all that. It really, the way I've got them in here, they're in a separate dictionary. I think it's called names. Oh, I don't know what it's called now. 200 yes. And there we go. We got a separate dictionary in there, and really all we need to put in there is the byte for the attribute and the count.
I see.
3 bits for the attributes and the name, and then 16 bits to point to the code field, etc. So there is an extension to that in the full version where it says, well, if you have one extra attribute, you're going to allow for 20, a 24-bit address or whatever, etc. But that's fairly well. I've never really used that, so that works in there fine. And as you can see, if I pop in the SD card in that one, even in that one there, I can mount the SD card and do a directory, whatever's in that directory there, etc. And that's just running out of 12K of ROM at the moment. Has lots built into it, even in that particular one, where it was very difficult to test out the forth and the booting and everything else without actually having real silicon. So but it seems to work quite well as such. So can you imagine that in that little chip? Wow, we can do a lot with it.
I see. Great. Thank you.
I think Travis has a question. Travis?
Yep. Hi, Travis.
I saw that you were setting a character delay. Did you know that there's 4 terminals out there that eliminate the need to set that? For instance, E4.com or Zeptocom.js, which are designed to synchronize with fourths in particular. So you don't have to wait for each character to get received properly and all that.
Yeah, that's I saw you mention that too, and I know that that's used in the past. But really, is that what well, that's better than having the slow terminal that really has to go too slow. But in my tachyon forth, I don't have any delays whatsoever, and so I much prefer just being able to use any terminal and hitting it as fast as it'll go. The way that it compiles, the way it handles it word by word, it basically means, and the way it searches the dictionary, for instance, and all that means we don't need any delays in there at all. And so I'd really want to keep the tools very simple. Any terminal. I prefer Minicom on Linux. It works very efficiently, or Terraterm on Windows, and 0 character delays, 0 line delay, and no
I have a
handshaking.
question. When you use the P2, are you using USB or serial?
Okay, P2 doesn't really have USB. It has USB smart pins, but it's it's not. It's really awkward to implement any USB type software on there. Quite complicated. Versus
Okay, I was just asking because I know that with if you're using USB, you don't need a specialized terminal because USB provides what's called back pressure.
I'm sorry. Can you run that by me again? I missed it.
Oh, I was just asking because you don't need special synchronization if you're using USB. And I don't mean USB where there's a little FTDI on the board, by being actual USB CDC.
Yes. I get you, because that is quite true. If you have, but normally the USB hardware is another layer in itself. Interestingly, the ESP32 C3 and C6 implement USB at the serial and JTAG level. It's pretty much doesn't do any much more than that. So it'll be really interesting to implement Tachyon on the ESP32C series and use USB serial, because it'll be a lot easier to implement since it's in hardware as such. And yes, we don't get that problem. But if you have a look at my screen, for instance, now, and if I reboot with my card back in, so it'll boot back up with the card, and So in this case here, it should come up with a full version. When I want to load something in, I normally just go to, well, here, let's see if we can just show this on the screen here. I'll go to a particular one here, just to show you the speed that we can achieve with this. I think this is one of them here. Okay, this will do. Come across here. So here, what I'll try to do is Visual Studio Code. And in fact, what I might do in here is put in, I'm just looking at something in here that I can put in that I haven't got in there already. There's quite a bit in here already with the multimedia, etc. Multimedia is running at the same time. It's outputting video on a capture screen here, etc. So I could go VGA and whoops, I did the wrong one, didn't I? Okay, let's get that back again. Okay, here we go. Bring this back again. Here we go. That doesn't look right, does it? Do that again. Okay. Don't worry. I'll leave that there for the moment. But the thing is, what I want to show you is the fact that we can load in code very quickly. So over here, I use the terminal in Visual Studio Code simply for scripting. In this case, I have a script that is a send script, which uses ASCII transfer to send a file directly to the terminal. Good thing in Linux, because of the way it's piped and so on, we can leave that terminal open. We don't have to close it. We don't have to do anything with it. We can just come along here and say, look, send ILDA. I think this might be one I can put in here. There's one called ILDA in there, which is to do with the laser light show stuff, etc. Okay, so I'll put in ILDA into that one, and hopefully, and that's going off to USB 0 over there. Okay, so USB 0, and that's it. It's all compiled. As you can see, that's how it went in there. That wasn't much, but normally even large source code will go in and compile in under a second, fraction of a second, and so we can see the words that are in there now, etc. And the ILDA words that were compiled, which were, I think, I don't know how many words, but within 200 words here, and too much on the screen, isn't it? Okay, so here are the ILDA words up there. So that's just compiled that code there, and that's why I normally do it. It's just I don't have to think twice. I just send it off, and even if I completely wiped everything on here, I do a complete cold start, take it back to the kernel, etc. I can load in all the extensions, nice and easy, extend, and initially, when it first puts it in, it doesn't do the fast mode, but then it switches to it after it puts in some extensions. So I can do it like that, and done. All right, so that's quite a lot of code that went in there, and 1600 lines. And now I can add the assembler, for instance. So I can do that, P2 assembler, USB 0. You can imagine this on MISC 5 as well. And then I'll load in my FAT32. I call it FAT32 since this is the way I use it in the flat mode, and put that in there as well. Am I happy with it once it's gone in? Yep. Well, there's a lot in there. It's all in RAM. I can type backup, flash, etc. But in this case, I type a Control F because I have a whole heap of controls tied into in here, and there's a backup to flash on Control F. So Control F, flashing, and now when I reset, it will boot out of flash. And so, did I tell it to reset? Do it now. And I'll just reset, and you can see up here in here it's detected the modules I put in there, all the extensions, etc. The assembler and FAT32. None of the extra media modules, but that's how I normally put code in, and it's very quick. So in these tiny little chips, we've got I don't know, this has only cost like $8 or something rather, or whatever it was from AliExpress, just for this lot of 50 chips. So you can imagine putting chips around. You don't have to. You can. It's a bit like the propeller has 8 chips, really 8 cores. But in this case, you can put those cores where you want them to, and just communicate via a single I/O to all the chips if they're fairly close on the board in the chassis, etc. Yeah, that's the idea there anyway. So. And you know, I can see it working really well on RISC-V. As you saw that interpreter part of it, etc., and just being able to implement the primitives, the different tools that I also happen to have a RISC-V assembler written in Tachyon as well. I can use that. There's quite a few different ways I can develop on this chip here. All right. So,
yeah. You had me thinking, Peter. What's the cheapest fourth on the planet? 10 cents is pretty close, I think. I mean, there are some. I know there's some Cortex. Yeah, there's some Cortex M0 pluses, but I think they're OT. I think the cheap ones are OTP only. They're not flash parts.
Ooh, wow! Okay. Yeah.
So there are some ones that, I mean, in volume you can get down to like 3 cents and stuff, but I don't. It's tricky. I like the fact that you can get these things on, 50 pieces for a few dollars, and it's
exactly. And you want a few hundred. It won't cost much to and the price comes down, of course. It was just easy just to get them like this, and really when you think about it, 5-volt part 2, it's like, well, we have interoperability, we can use them in different designs. Everything's on board, the oscillator, you name it. When we look at it all, everything's on board. We only need power, and away we go. Done.
Yeah, I think 10 cents would certainly meet the cheapest fourth on the planet.
Probably right then. And when I design a board, I like to spread functions around, like even just on my P2 board, I had a little USB, a little tiny micro, which was originally just a supervisory micro, just a little QFN20. It's a Scilab's 8051 type part. It also ended up implementing USB serial. I've got the serial version, but it's over $1 just for that little chip. And really all I really wanted on there was a chip just to look after some boot functions and power up functions, just to make sure everything reset properly and so on. And this type of chip, do it no problem. In fact, if I just use the 203 or the 200 series with a USB on board, that can do that too. So I like to put chips all around boards just to look after different functions. And propellers made it a lot easier in that I don't need to, but in other designs, it's good just to have an independent function, and that's what it's doing, and will keep on operating, especially in the fail-safe type situation. Excellent. So next time, I hope to have this all up and running. But yeah, see, if I had more time this week, I'd probably have something running. But next time, certainly, yes.
Thank you very much.
We'll call it 10 cent for, shall we?
Very interesting.
It's a lot of sense.
Yeah.
Not too much sense.
Thank you for the heads up. Great.
Hey, Peter, you're around Brisbane or something?
Brisbane,
yeah. I've been working in Singapore for about, I don't know, 10 years or something, and I've just moved back into Brisbane. I was kind of surprised to be here in the same city. Yeah.
Oh yeah. Oh yeah. You call by if you like. Yeah. Just message us on Messenger or whatever. There and come into the workshop. It's like full of parts. I've got parts.
You got parts.
I think it's all like there's all those drawers down there. There's parts drawers up. If I turn back up here, there's parts drawers up here. And it's like I've got parts everywhere, and I've got boards and you name it. So yeah, it's just like I used to do a lot of prototyping, but production stuff. Now
Yeah, so you needed stuff.
I can just play, and the trouble is sometimes you know, in the past when I was working on a project, you had lots of focus and you'd want to play. Now I've got I can play, don't have a lot of focus, but now I made myself really focus on this RISC-V, get into it.
Yeah. Oh, it seems like fun. Yeah.
Yeah.
Interesting.
Great.
Very nice.
Hey, I see daylight in Brisbane.
Yeah. I got some light coming up as well.
Yep.
Yeah.
Behind me.
Yeah. That's it. I can hear the birds, etc., and everything else, and you get the kookaburras going and laughing at you.
Yeah, that's true. It's just about that time. Well, 7 o'clock, so it's in the morning. So.
Yep.
That's right. It is too. Yeah. Good.
Yeah.
So if any questions and any feature you'd like to see, and this thing I mentioned about the manufacturer, half jokingly, because they're rather hard to communicate with, but sometimes you can, and so it'll be interesting. You say, there it is, free, no, all works. Why don't you just build it in? Chips, you can just I can always put it to them, and that'll be interesting. So you imagine going to AliExpress, ordering 10-cent chips, all built into it.
Yeah, that'd be pretty convenient, wouldn't it?
Yeah,
I think these things are so cheap. If you drop one, it doesn't really matter, right?
Yeah, well, that's right. I dropped them. Just like, well, they're gone. They're gone. And it's like the other packages, the small packages they have there, their little. I do like TSSOP20. I do like that, but just for prototyping, because I have my 50mm matrix board in a 50 thou matrix board that I use. I thought, well, I can prototype on that very easily, and this stuff here, and you've probably seen it before. One I designed, it's actually very cheap to make, and I had JLC PCB make up a whole heap of these ones, and they've got large holes and smaller holes alternated around, but I can put surface mount parts on there very easily, like that, and
that looks
prototype
interesting.
with that. Yeah, I call that my micro mat. So it's like I'll try to keep in this camera all wrong, but yep. So
the camera doesn't pick it up very well.
Yeah, that's right. So basically, it's you can see right through it, right? Okay.
Yeah.
See that, and it's got small holes, so I can get the little 50mm type headers I've got here. 50mm headers.
Oh, the kind of half size ones. Yeah.
So here we go. Headers. So these are the really fine 50mm ones, and I can put that straight into the board. But then when I put the big headers in, they're not tied or loose or anything like this. None of them are actually tied or loose, so they all go in. I haven't pushed them in properly at the moment, but very, very easy. And I got these boards that are totally plated through, double-sided, of course, and no funny little power tracks which never suit whatever you're doing anyway. But because all the matrix boards seem to have all these things made up for dip packages, etc. I just did one, and also gold flashed. So just get gold on it and makes it very easy to solder up too. And yes, and you know what? Ends up costing me about 30 cents a piece. It's like I'm popping a Jake. If I could just buying a board like that with single-sided copper, nothing else on it, hopeless stuff, it'll cost you $6 just for a bit of board, and it's like, that's just crazy. This is what they should be selling, but then they probably want $30 for that. It's just like, well,
they couldn't sell it for a few cents, could they?
No, that's right. Yeah. So,
unfortunately,
yes, I've got a whole heap of those.
Nice out there.
Sorry. Yeah. So prototyping wise, surface mount's always a problem, and at times, I will design little modules for certain boards, etc. So
that's the manual for the cart. Are you gonna
Travis?
build it today, or are you gonna? I can't use it unless I build it.
I think Travis is not on mute.
Oh, okay, yeah, that's right.
We talked
Oh,
about having a while having one.
Let's see, let's see, let's see.
Yeah. So the Peter, I noticed. So those chips run at 3 volt and 5 volt.
Yep.
That's pretty cool.
Yeah, and that's what attracted me to them. You know, it's 5 volt operation.
Right.
Nothing else. No clock oscillator, no external memory.
Yeah.
That's it.
But the ADC as well. I mean, if you want to buy, if you run out of ADC channels on your main processor, which happens more often than you think.
Yeah.
Something like the RP2040 that's a bit lack on the ADC inputs.
Yeah.
You use that as a controller for the ADC.
Yeah, and in fact, like I very rarely use any I2C dedicated chips such as A to D chips because they're so expensive. It's easy to get a big micro, program it up. I can put it in I2C protocol or even just serial. In fact, I have some designs which just spit out the A to D just automatically on serial, go through opto isolators and solid state isolators, and so I can have isolated A to D without having to talk to it. It's just sending me the stream, and I can, take the readings.
You don't even set it up or anything. You're not even trying to, run like a separate sensor and configure it and all that sort of. Apart from paying for it.
Yeah, that's right. So you can imagine this little chip being used with the fourth on there, and you type in a couple of lines of fourth, and you say back that up into Flash. And now it is, and you can put it on the other side of an isolation barrier, and it's doing all your A to D sampling and any filtering that you want done on it. But it's done. It's all beautiful. Yeah. So that's the idea. That's how I use the chips.
Nice.
Yeah. And I forgot too, I have plenty of other RISC-V. I had these quite a while back, and these are the Buffalo 808s, but they're triple core, and they have a high performance core, a medium one, and a low power core, RISC-V. Way complicated on the documentation. That's why I want to start with something little and then build up to all these more complicated chips. So, you're wrangling with the data sheet. Yeah.
And if you look at the like higher up the RISC-V area, there's a lot to some of those. Yeah, a lot of optimizations and stuff. You just want to not get stuck with them. Yeah. Not at the beginning.
Yeah. I think there's going to be, as we can see, we've got everything from low end to high end in RISC-V. We don't have that in ESP32. We don't have enough I/O. We don't have enough this or that. ESP32 is really nice for what it does, and I do want to use those little chips for even just little micros as well. But thing is, they always need an external clock. And they're 3.3 volt, and you've got integrated flash, stacked die flash, etc. That's a good thing too, but it's not a simple little circuit, and an 8-pin chip you can beat that on. But RISC-V, I've had that for the 64-bit ones as well. Those modules as well. Lots of different RISC-Vs. I've got the Giga device ones, which seem to be hard to get, etc. Giga device kits. I've got a stack of these ones. Got a stack of different RISC-V, except ESP32, which I'll still have to do.
Yeah.
It'll be fun. This will be fun, just getting this 8-pin chip going, and maybe that's a hackaday thing where I can come along 10-cent fourth.
Yeah.
Interesting. That's right. Yeah, we can do it like that, and just the fact that somebody can plug it in and start talking. You can't do this with Python. They like to put that on the RP2040, but it takes up most of the RP2040 resources, and it's not that fast. It's quite slow. Here you're talking about something that's fast. Great, you've got room left over for, and you can use it off bus, etc., and talk to it via terminal. It's like, what's your development system? Nothing. You got a terminal, go for it, plug it in. Yeah. I like the concept.
Yep, sure.
So sorry I didn't have anything really to show you, but you know, just it's good just to get to this point anyway with having the chips here now and information and just really getting my head around what I might need to adapt.
Yeah, it is inspiring anyways. So yeah, thank you very much.
Thank you.
Christian, now open the mic.
Yes, Peter. I know you had a lot of interest in propellers. And I was asking myself, if we take 8 of those small 25-cent TACOS programmable chips, could that replace a propeller?
You know, different thing, but in certain applications, yeah, you know, like you know, sometimes on the original propeller we used various cogs for serial, just for this or that. For instance, the 307 version of this chip here, just to give you an idea, does come in smaller packages, but it has 8 UARTs on it. So why would I would just use UARTs and all the hardware that's in there. That can do a lot of things. Yeah, you know, already.
It would almost be a scalable propeller.
Yeah,
you want 4, you want 8, you want 16.
Yeah, and that's a problem with a propeller chip. It's very expensive, and you need your power supplies and your clock and everything on there, external memory. And so this makes it a lot easier because when I design boards, you know, fine, you can have propellers on your bench top, etc., and all that. I build it into products, a lot of products in the past. I haven't built the P2 into any real product. I intended to, but I haven't ended up using it because it's quite a beast. But I can see that there's a lot of applications where I can use these little chips, the slightly larger versions, and maybe a combination of that and the ESP32, etc. It's just, you know, and talk to the lot of them in Forth. Yeah.
Okay, thank you, Peter.
All right. Hey, Christian. All right.
Yeah, really interesting. Thanks. I'm glad I glad I connected.
Yeah, well, it'll be more interesting next time. That's right. That's for sure. And I will have it
sure.
up, yeah, on the bus as well, so we can just talk to them and see them all working. Yeah.
Yeah, perfect.
No, it will for sure be my next experimentation when it's available.
Yeah, that's right. Well, it won't be long. It's, you know, I can, you know, I'm almost at the stage where I can put, you know, Forth on there and running, and what I did with Tachyon right in the beginning, Christian, it was very simple. I just wrote just enough in the kernel, just to run some primitives, just to run some tests, and I had the thing running up in days, you know, and then I just slowly improved over the few weeks. But most of it was all there within the first few days or weeks, etc. Yeah.
No,
I'm saying
it
it's going to
would be
happen.
my next experiment because I found TACOS so easy to use.
Yeah. Oh, that's good. Yeah. Well, I find it easy to use and interesting too. Just talking about Forth just in general. I was using another Forth on the propeller thing, and it was, and I just found it very awkward and very slow to load and awkward. And I didn't have any one particular source where I could just compile that to generate a new kernel. It was created with all these special little helper tools and everything else and so on. And I wrote and it wasn't fast. When I actually put it to use, it was really slow. I thought, what's going on? So I wrote a, you know, decompiler, etc. for it. And when I decompiled it, it was like I could see the source properly then, and it was like no wonder it was a mess. And you know, the thing is that when we for production use, I build this in production. I've got to have a really proper Forth, a fast Forth, one that fits in that memory, etc., and is easy to develop on. You know, so. And that was the whole idea. That's why I started Tachyon. Otherwise, I would have been quite happy to use whatever was there already, just to get going. I'm a bit lazy like that, but then once you get going, Yeah. Are you any guys using Forth in commercial products at all?
So I've got I mean, a lot of my products have got big teams and have got lots of engineers writing C++ or C, but what you'll find is that Forth, the production test interfaces are often Forth engines, right? So often the production test guys, I mean, rather than just have a canned production test routine that's always wrong, they want a command line interface. And you can obviously write a command line interface, but the problem is that if they want to do something just a little bit different, Forth gives them, and it's, in terms of number of lines of code, it's not much different between a standard command line parser and a Forth engine, in terms of number of lines of code. And so I'll just put Forth on there, a simple Forth as a command line parser. And then some of the dev guys use it because they want to be able to poke the hardware to find out why the C code's not running or working. I also had a case a couple of years ago where, and I didn't intend to write a Forth, as is often the case. The mobile app guys wanted to simulate hardware conditions on a underfloor heating controller, and there's a lot of I/O on there, and you need a lot of specialist equipment. And some of the production test guys, some of the mobile app testers were in America, some were in India. And they were like, I need to simulate these conditions. All right, well, for a start, you're going to need a 240 supply. You're going to need all these valves. And I'm like, this is just, they're not actually testing the hardware, right? We've got a separate team that tests the hardware. So I was like, right, okay, what I need is a command engine that was sat on the end of a Bluetooth link. So I just hacked up a simple Forth interpreter and allowed them from the test tool that I'd written before from the PC to connect over Bluetooth and set it in a mode where it simulate those hardware faults, so they could test the mobile app, right, on the Android or iOS. And that actually got ported across to another project I was doing, and it got expanded a bit. And I've ended up as a I didn't intend to write a full Forth, but that's just the way it happened, and it was the easiest thing to do, so. So yeah, I mean, this is, and I've also got, as well as sort of shipping products. I also sometimes use it if I've got a test kit. My choice, with a Pico, for instance, the Raspberry Pi Pico. Hack one of those onto a custom board, and you get the board made for a few dollars out of JLPCB or somewhere. Put one on as a piece of test kit to measure some, readings. Like a bespoke data logger, and sometimes you can do that in MicroPython, but often you end up, I don't know, fighting against the system, and I needed an RF logger to log and generate RF signals, and I really wanted to put all the code on the PC. Right, I don't want to run it on the target device. And what typically has been done before, a load of the code ends up on the target device, and then you have to firmware update the target device as the spec changes. So instead of it's Travis's Zepto Forth on a Pico, and there's no hard-coded code at all apart from Zepto Forth, right? It's an old version of Zepto Forth now, and because Travis moves too quick for me to keep up with him. And I just download a bit of Forth stub code, write it into Flash, and it detects whether there's been an update in the host program for the PC. And then it goes, right, there's been an update. You're going to need to wait, another 30 seconds for me to change over the definitions. And effectively, I've been able to pull most of the code over into the PC, where it's easy and fast to change. And it just acts as a little stub between the RF chip, the RF transceiver, and the PC. And there's a tiny bit of real-time stuff in there, things like reading the RSSI. But most of the stuff I've been able to avoid. The PC is effectively non-real time, but it just acts as a bridge between the transceiver chip and the and so there's those sort of things that are, you haven't got time in a project to spend a lot of time writing tools, right? But you still need the tools, right? So I tend to find things like Forth are quite useful for doing stuff there. as well.
That's what I call rapid prototyping, but software prototyping.
Yeah.
You can't really do it, you know, by the time, you know, you set up everything, and you have to wrangle the compilers and everything else and so on. But Forth, it's just there, talk to it. And I start from, you know, I have, you know, the top up, top down type concept, but start from the bottom up. When I try some simple routines, yeah, that's good. Change that a little bit, build up, and it is very rapid prototyping. Yeah. Same with the even when I did the little pick chips, I had to do the high voltage programming thing on it because we use them in production, and we had so many problems with different programming tools and the programming software with gigabytes of it, and it wouldn't run that particular tool, and it was like, well, I give up. And now that I've just written some routines, I just bit bash some commands through. Yep, that works good. That works good. Throw the data in, etc. Check that out. Ramp up the voltage. Do this. Do that. It was very rapid prototyping there, and then now I've got complete control over programming of that OTP or flash or whatever, the different voltages and testing of it. I can program single location. I can manipulate anything I want now. So much more versatile, and I think that took me a fraction of the time it took for me wrangling with the microchip MP Lab tools. You know, it was such a mess.
Yeah, I'm well aware of MP Lab.
Yeah.
One of many. I mean, you know, we use a whole bunch, lots of different and I use chips at home to do robots and other things, and yeah, wrangling with. I've been writing C for a long time professionally, and I'm like, it's just terrible. And the people who only know C, they don't realize how bad it is. You know, I mean, you know, it's a major achievement when you flash an LED with it when you've got a C project. With a Forth guy, it's just like, well, you just load the Forth on and just toggle the pin. You know. Anyway.
Yes, and it's really, really simple. And I show that little one-liner where I just type it in as a one-liner without even creating a definition, and that always amazes guys. You know, it's just like, well, there it is. I just say begin. You know, 5 high, 100 milliseconds, 5 low, 100 milliseconds. You know, again, return back. You know, it's one-liner. Just type that in, and away it goes. Blink, 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 blink. You know. So yeah, that's right. Rapid prototyping, and you know what I like about Forth, it's because so the type of Forth where we have it's threaded 16-bit addresses, etc. It's a one-for-one correspondence as we to the code, source to the code itself. And so when I look at the source code, I know exactly what it should be doing here and here and here and here. A bit like assembler, whereas versus the compilers or even MeCrisp, because MeCrisp generates all this machine code, etc., and so on. There's no one-to-one correspondence, and here I can generate code. I can debug it very easily. I know exactly what it's going to do. And I can even patch it as well. I can't patch any of that other code. So that's part of the prototype. Out in the field, sometimes that's what you need to do. You know, you're just out there, and I can patch that. Yeah. Yeah, all the tools, the MP Lab tools are huge. I had one for the Scilab's 8-bit chip, and of course they try to include everything else, and they called it Simplicity Studio. It was anything but simplicity, and the real simplicity is Forth. Forth is, you know, and I don't know what the problem is. As soon as you mention Forth to somebody, they go stacks, reverse polish notation. I don't even think stacks or reverse polish. I just think, you know, as I said, you know, 5 high, 100 milliseconds. You know, it's what's wrong with that? It's and you know, anyway, but that's all right. I don't know why people have trouble with the concept there. So it's taught. Here it is, algebraic notation, etc. You know, we don't speak like that. I always say I go to the shop, we buy 6 apples and 4 bananas. You know, we don't go, you know, buy dot bananas brackets, 4, etc. So yeah, to me, it's more natural, and it's a bit like driving a stick shift manual. To me, it's automatic, very easy. For other people, they can't get their head around it. They have to have an automatic. Yeah. Different folks. But we have fun. That's right. I never have fun with compilers. Never, ever. It's just a headache. A bit like filling out forms.
Yeah, I think that it's always, I mean, effectively these sort of algo-derived languages have done sort of a lot of people a disservice, because that's what they think code should look like. And the problem is, I mean, I guess people who do Lisp or Pascal and also complain about this is in the fact that people who only know one thing, they haven't got a concept of how it can be different. You talked about, field patching of units. We've got, millions of devices, and if you have a problem, it's really hard when you've got a monolithic C compiled binary to do anything. And I know Peter Forth posted something about the patching of satellites, but it applies everywhere, right? And you've got a problem that you can't necessarily debug them. I mean, sometimes on Linux systems you can SSH. But, there's a whole complexity, a massive complexity burden there, and you can't go very far into the system. Especially when you've got multiple pieces of components. Often you've got, it's not just one chip that's running everything. I mean, I'm as a software engineer, I want to centralize everything, so I've got control of it. And having multiple distributed systems can cause problems or extend development times. But conversely, you've never got that situation, and you can't get access to these edge and far edge devices in a system often without something like Forth. And there really isn't a simple solution. I mean, there's things like the WebAssembly guys were looking at, and I know there's been some development work on WebAssembly for embedded targets, but it's a really clever technology with an abstract machine, a virtual machine. But it's like I've seen this before. It's like there are simpler ways of doing what you're trying to do, and Forth is one of those.
Yeah, I sometimes think too that talking about WebAssembly, it just takes me back to the days of when Oracle introduced Java. Oracle took over Sun. Mitch Bradley developed Open Boot, etc. Here it was, and this is really great concept. Forth there and debug the hardware, but then use it for Open Boot, and then it's almost as if decided that they'd take that concept and they ended up with Java, and so and we can see all these other concepts, and they have to keep on molding it into their that's right, into their traditional view, which is not really all that well, put it this way, even if they did, they could still have the assembly language, okay, rather than trying to do something else, and that way you can still work at that level, communicate with it, see what it's doing, and everything else, and work at a higher level if you like. But yeah, trouble I had with Parallax with Propeller, they really just don't even like the word Forth. It's just like, come on, we love our C or whatever it is, etc. Spin in the case of chip, but it's really difficult. But as I said, I like it because if we're back here on Tycho's, for instance, if I type in that little flasher loop, for instance, let's make it an actual word here, flasher, and you begin and you say 5 high and 100 milliseconds and 5 low, 100 milliseconds, and let's wait till we hit a key and all that sort of stuff. But when I see that, I've got a one correspondence to it. I've got, there it is, 16 bits, that's a 5, high, etc. I can come in and just patch these things too. So sometimes when I don't even have the source code, I can just decompile that, whatever, make a quick little patch to it, and away I go. if I do that in MeCrisp, it's like, wow, lots and lots of assembly. Yeah. And what does it do? It says it generates all that assembly, and all it has to do is just wait anyway. So it doesn't need to be, as fast as assembly. Yeah. Wow. So what are we doing now with the program? Is we still
I
got,
think yeah. I mean, it's effectively we've run off the end of the program, and we're now in sort of, if anybody's got anything they want to show,
Just in sort of
yeah. So if there's any problems anybody's got, or anybody's anything they want to show, then this is sort of the tail end of the meeting, past the agenda.
we're just rambling now.
probably think of a better word than rambling, but yeah.
Oh, we're having fun rambling. Don't worry about that.
Peter, could you post, you see the links you've got for these micros in the web links? Could you post that somewhere, either here or on Facebook?
Oh, yeah. No, we've got that, for instance, there's that one there for that particular micro. And so if we go to that one there, and then we'll go, we got the chat stuff. Okay. I'll pop it all through on what's the best place to post it all? On the chat, or?
Well, it's probably you could do it in. You could probably put it in Facebook. I mean, there's a reduced group here. I think it's sort of this sort of stuff. I did see a post about a week ago, I think, but I didn't really click that these parts were so cheap.
Yeah.
Especially the sort of low end ones. So I think it's really cool. And seeing I can get 50 of the things for almost no money at all.
Yeah, that's right. Yeah. I've never used that. Oh, sorry.
No, carry on.
Yeah. Oh, I've never really, used AliExpress before, because it was like, so, I thought it was going to be a mess, but I gave it a go, and I ended up ordering all this stuff, etc. And you just have to, I double ordered some things, because you just have to be careful when how you order and what you click on and everything else, because they always try to, get you like that. But yeah, it came through pretty quickly and everything. I'm quite happy.
It's generally pretty good.
Yeah.
Actually, I actually worked with when I was in Singapore, most of the time, I was working with an e-commerce startup. And we ended up getting bought by AliExpress, well, actually by Alibaba, the parent company.
Oh, yeah.
But yeah, if you fall into their line, and the amount of optimization they got in their supply chain is just unbelievable. If you fall off to one side, you get lost, your package disappears or whatever. But they usually cover that. That's all right. But I've had heaps of stuff come through, and it's generally been okay, except that they run a marketplace, so it depends on the seller. If the seller's a bit dodgy, eventually AliExpress will notice it and they'll jump on them. But you might be one of the ones that get a problem. But these guys, and these are genuine dealers and whatever that are just using AliExpress to get stuff out of the country. It's not their problem.
Yeah. It's just amazing. It's just, normally over $15 here Australian, whatever, it's just free shipping, and depending on what it
free,
is.
Yeah.
And before I was using Amazon, so like, I can order it, like on a Saturday, get it on Sunday. It's good like that. But check your prices, because they can be quite expensive. But AliExpress has, especially for electronics, for components level stuff, much better.
Yeah, it's pretty cheap. I remember when it was a few years ago now, but they do this 11/11 promo, like the 11th of November promo thing. And on one occasion, AliExpress hired for a week, I think it was 20 or 30, can't remember. No, it was more than 30 flights from Etihad. They hired a whole lot of stuff for what do you call those things? Big cargo planes, the biggest that Eddie had. And they just said, right, we're going to have 40 of those, and we're going to run them for a week, and that's going to get everything from China to the US and to here and various other places. We didn't get them in Singapore; we were too small. So we heard about it, and it's like when they decide to do something well, they also screw things up. But no, everybody does that.
That's true.
But,
That's true.
yeah, kind of interesting. Kind of interesting.
Yeah, quite impressed too. Yeah, so I put the app on my phone, and now I just do a lot of shopping on that one as well. You know.
I mean, they're a bit annoying because they keep shoving ads at you and all that sort of stuff, and trying to get you stuff that's unrelated and all that. You just have to ignore all that crap.
Yeah. Well, as I said, you know, like even when it says, you know, like here it is, it's $1, and you think it can't be $1, you know, like the LCDs, but then you got to select the right particular one, etc. Make sure you got the right quantity and the right one. It's okay, you know. Once you know that the way it operates, it's fine.
Yeah, it just takes a little while to get used to. Yeah. You know, you end up with the wrong model, or you end up with one, or whatever. Or you find occasionally it's a good price, but then the shipping, like some of them have got cheap shipping, and some of them have got the shipping is like 4 times the price of the thing. So you got to read both numbers. Yeah.
Exactly, and you look at that, add it up, and you go, but you know, then they say, okay, you go over this amount, you get free shipping. Okay, well, it makes sense to do the free shipping one, or find it elsewhere, and you know the price of it, and but yeah, I never really spend a lot on any one order. You know, I think $60, $100 or whatever. You know, and you're not going to do that too many times if it comes through wrong. You know, so it works out quite nicely. So I had all this stuff, all these LCDs, all these things, all these RISC chips. I've got a couple of those big 307 eval boards, which I don't really need. I've got, you know, but anyway, I've got. I'm not worried about that. I've got a few hundred of these little CH32 003s, etc., and 16 pin and different things. That's okay. They're cheap enough, you know. I'll drop some on the floor. They stay there.
Yeah, I noticed Ali and eBay have got for the 003, they've got a small dev board.
Yeah.
22 pin dev board, by the look of it.
Yeah. So there's but and if it's got the link, trouble is with the 00. Well, that's what they need, their special link device, and you know, the larger board I've got there, that one for the 307. I've got that particular one there. I've got the dev board for that, and that's got the built-in link into it, so you can just program into USB, and that's how I loaded up the eCrisp into it. And so the CH32B307 eval board, eval up here, and so that's the one there. And that's one of the ones. That's not the particular one I've got there, but there's a price there for one. That's more of a module to build into things. I think it's a bit pricey, that one. And but yeah, that's right. Yeah, you can just get all the different ones. So it's got that other one I saw before had the link built into it, which is, where is it now? That one there, dev board, there it is. Some prices are $20.
Can you patch that? Can you patch? So if you've got the link thing in it, can you patch that across to something else and just use the same link, or you just buy a separate link stick?
Oh, for the programming stick, you're saying, or
yeah, whatever they call it.
Yeah, you can, because like I've got it here. So here's one here with it in a little case, etc.
Oh yeah.
And really, that's just, but you can use it for serial as well, you know. So it does all that.
Oh, okay.
But
yeah,
because it's basically the chip, so they have pins on the other side for RxTX, but then you've got your link stuff. And this particular 0003 chip, or whatever it is, doesn't use a clock and data. It's just as a single IO one, so it's different, you know, because it's has less pins on it, etc. But it
Oh,
does
yeah,
all
so
that.
it hasn't, it sort of cut
Yeah.
down because otherwise you wouldn't have any IO left.
Yeah. So they have their own particular protocol for it. I want to work that one out too, because I want to be able to even, reprogram the chips directly.
Oh, you want to talk it directly.
I want to,
If you can get if you can figure out the protocol.
Yeah, exactly.
Hopefully you don't have to read Chinese to do it.
Yeah. Well, somebody started to have a look at it, etc. And that's good enough because in fourth, I know that once I've got fourth and I've got the product, it's right. You can make things happen very quickly. Yeah. So that should be good. Yeah. So different boards around. What are these different boards here? So that particular board I've got there has got the link part on it.
You've got you got this one. Oh, okay, it's attached. So it looks like it's attachable. So you can do it either way as one unit, or you can split it and use it for something else.
Yeah, exactly.
Oh,
And
okay.
it doesn't.
So that's 307.
Yeah.
Right. Yep.
That's right. The 307. I think actually I did have a web shot. Yeah, web shot of the one I've got. Yeah, there it is, just there.
Same thing. Yeah,
etc. Don't need those best chips there, but yeah. So, so the Ethernet socket, the PHY on it appears only 10 megabits, but it just does have a PHY, so you can get by like that. And you can put on a high speed PHY, and then of course USB, etc. So you can use the
a couple of layers and at the other end. Yeah. On the right hand side, that's your ambiguous vertical, but you've got two on the left as well. Geez.
Yeah, that's it. And you can imagine so that on that particular version there for that that board, where are we? The 307, it has the high speed and full speed device, and so it could be quite useful to have that in a smaller version of that chip. Perhaps I think it's called back in here somewhere. I've got it somewhere. It's not going at the moment because I've got the zoom stuff in the way. I'll get the zoom out of the way. And okay, so here we go. The in the different packages, etc. I think we've got whatever they've got in there, but it's a 200 series. So one of these 200 series, whatever they are, they'll have 144 megahertz, and they'll have everything on board. I don't know. Here we go. Got a host device there. That's one particular version, but yes, you get them in really small packages, QFN20. That's nice and small. So yeah, so you can build all those linked devices, and if I have my fourth on it, you could reprogram the whole thing in full. Full UART. Well, I don't know how much they are, but they're not too expensive. I guess I imagine that if I went to AliExpress and asked them about CH32V203s, for instance,
probably still pretty cheap.
Yeah. So AliExpress 20-piece lot of these ones here, which is the larger package, etc., and so on. Yeah,
you get to choose your package size. Yeah.
So that's a 20-piece, and I'm sure that I can get smaller packages, etc. There we go. Smaller packages.
That's
there.
$25 at like 20 of them.
For 20. Yeah, that's right. So about $1 a piece, and that's because you're buying a very small quantity. When we buy in larger quantities, you just see that price just drop straight down.
Oh, it drops down.
Yeah, a lot. Yeah.
But even the initial price to play with them is not. You're not worried about it, right?
Yeah, that's right. That price, what you're getting, 32-bit chip with all that on board. It's, I think that's a particular one. Did we look at that spec on it there before? But what is
that the one you had? Oh, that's is that the different one?
Well, the 200 is a slightly smaller version to the 307.
To the 30, yeah. No, I meant the board you had.
Oh yeah, so the board I've got's got the 307 on it, which is the
307.
Two USB devices and a lot of other stuff. And so they're all, you can imagine, you can pretty much choose your 10-cent chip or your 50-cent chip or your $1 chip with everything on it, and
just use which you need, and then you could afford to ignore the rest while you're
Yeah,
developing.
that's
Just use the
yeah,
bits you need.
exactly. Yeah, you don't use all that stuff, and you know, like the ESP32s would be really great if they had lots of I/O on it. They had a chip like that with stacked die flash on there, as they do, and 400K of RAM. Yeah, I'd be using that all the time. Yeah, but certainly I can use the ESP32 for the small things too. Much like, except they're more like they need an external clock, you know, and that's why I like these ones. And internal, everything's internal, and you can run them on 5 volts. Very good.
Oh, okay.
Yeah.
Oh, yeah, they got the voltage too, flexibility. Yeah.
Yeah. So be very good, and you know, just even you know, when you look at that, you even have some DMA on there as well, which can be pretty handy as well. Yeah, 2K RAM
one
is a bit
channel.
higher, but compared to the 8050 8-bit type chips, which only come along with, or PIC chips, you're lucky to have 200 bytes of RAM on some of those chips. So this is doing well. Yeah, excellent. Yeah.
So Peter, I'm sure this is kind of an old question, but how do you handle soldering that? I know I like the prototype board that you had, but do you do oven or do you do like the magnifying glass version?
Okay, yeah, both. I love even just manually syringing solder paste onto a board, popping parts onto it. The oven, I have a 4-minute timer. I have it on, $30 oven. Bang, put it on, 4 minutes, comes out beautiful. But when you're prototyping, yes, you know what I use? I use USB be what a Pine Store one, but they're like a TS101 or whatever they are.
So you have a steady hand.
Oh well, look, once trick is always to put a tin of pad, put the chip down, and tack that on. Don't worry about how good the soldering is. It's tacked down in place. Tack down the other corner, and come along and with your fine solder. And in this case, I'm using a tip on here that's got a. If you can see it, it's a bit of a flat tip. It's really good. Yeah. I can do all
like a
in
knife
one
tip?
go.
Okay.
Yep.
So do you do the wave?
Well,
do you do the wave version and then you use the solder wick to pull off the extra?
Well, that's what I used to use back in like decades ago when I would do that. But now with this is fine, very fine, temperature controlled. It has a little 32-bit chip in there anyway. Just for controlling temperature and everything. But the thing is that when I do it, I might even post a couple of little videos just showing how simple it actually is, and that when you come up, flux is gel flux. It really makes a lot of difference. If you touch it up with a bit of flux, when you come along with the solder, or you like to say solder, but way it goes, just flows. And especially on this sort of matrix board with the gold and everything else and so on, it just is. Yes, thank you very much. Yep. And
now, was that board something you designed, or did you buy that from somebody?
Oh yeah, no. I gave up getting decent board anywhere, and it has nothing in 50 mil. And 0.05 inch, and so I thought, well, I'm just going to design that, and
nice.
in KiCad, and like I said, it's big hole, little hole, and the way it's done, it just makes it really easy to put on SOT23s or any small SOICs and different parts, and also too with my P2 at the time, I designed it there. Well, this is one of the original versions with 100 mil headers on it, but there's another I can't hold it up, 100 mil headers on it, and, but there's an inside line of pads which are 50 mil headers, and so you can break that off. But so the later versions basically didn't worry about the 100 mil headers on there, just had the very narrow version. I've got some here. In fact, I'll dig one out just to show you. Let's see what here we go. So here's a board. No 100 mil on it. It's got 50 I can do a surface mount solder with these ones here, if you can see it clear enough.
Yeah, you got the bracketed.
Maybe underneath, yeah, okay. But in fact, actually, this will be easy. I'll put it back on the share screen with
Yeah.
I'll come back and I'll put it on the camera there again, and I think you can probably see that a bit better. Yep. Okay.
Oh yeah.
So there it is. So that
Nice.
really fine stuff. And then you've got this board here
Mm.
that goes onto, and I can just solder it straight onto there, or I can use the little 50.
So you've got
and the board as you get. Yeah.
So it's just an alternating large
Yep.
and fine.
Wow.
You see
Right.
that?
Yeah. Okay. Yeah. Now I can see it. Now I couldn't see it before, but I can see it. You can just about see through the thing.
Yeah. Exactly. Yeah. And I wasn't sure whether they're going to start charging me a whole heap extra for drilling all those holes, and especially on that. But they just, I got a whole stack of them back, and it was like so cheap to get them done. It was like, wow.
Wow.
That's
pretty cool.
And that's just like a thin. It's just a regular thin FR hole or something.
Yeah, that's right. I've probably got the, I've probably got the keycard stuff up here too. I'll see if I can just bring it back up on the screen here. So I'll just get it up on this one here first. Let's see, a recent one, Micromat. Micromat. Right, come on, fellas. Where's my Micromat?
Neat little design. That's
up here.
Why hasn't somebody done it?
Well, yeah, this is always the thing, isn't it? It's just like, here we go, Micromat project. Let's go get this one up, Micromat, and see what comes up here. Bring up the PCB, one of the PCBs here. Okay, so hopefully that's it. So I'll bring that across to this other screen now. Okay, you can see that?
Yeah.
Yeah, so
wow.
That's the idea there. And rounded up some of the corners here, as you can see, for clearances, and it's just beautiful. So you get 100 mil up across here, 100 mil across there. And then you put your SOIC pack straight down on there and just touch it with a bit of solder, and away it goes, So,
wow.
And so when I put the 100 mil in, the holes are big enough that they fit in there. And of course, the 50 mil ones, if I put in a 50 mil, 0.05 inch,
fits right in between.
Every alternate one is a big hole, but that's okay. You still solder it, and it's still mechanically strong. Yeah.
Yeah.
Yeah. So
That's a
I had to go and develop that myself because nothing around, and there it is, Micromat done whenever I did that one. But yeah.
Oh, part number.
Yeah.
Mm.
Oh, well,
Nice.
that's the size of 3.75 by 2 or whatever it is, inches,
Oh, okay.
etc. And the 100 and mil and 50 mil parts on it, etc. And that was done back in whenever I did it. Yes, I can't remember, but yeah, back in 2019 when I was prototyping with all this stuff here. So I have board, so I just put that straight on, and really nice ones, and prototype with it. So that's why I've got these chips, these RISC-V chips in those SIC packs. I can't find the other ones. They're that cheap. I threw them down somewhere and I can't find them now. So
makes it accessible for those tiny chips with the layouts.
Yeah.
Nice.
So I can post up the link to my files there, and anybody can just go get those done.
That would be nice. Yeah.
Yep.
Cool. And then, are you doing any more work with the bus communication? That's something that really fascinates me, is to be able to integrate multiple architect, like a RISC-V with a P2 with a RPi Pico or whatever. I really like the idea of the communication, but I can't seem to wrap my head around how to get the protocol working, because I have some 485 chips, and I was working with the P1 development board, but it's like I can get receive working, but the transmit doesn't work for some reason. So I'm missing something there.
Yeah. Well, because 485, I sort of have in a lot of products, and you have on the propeller, I've been able to implement a lot of channels of 485. I just use two IO, one for the RxTX, and another one just to the transmit, receive on the 485 chip. And so it's very basic. You what
Yeah.
you need to do is send something serial, you're in transmit mode, etc., and receive mode. And of course, you know, in industry, you have a lot of simple protocols and, you know, Modbus, etc.
Yeah.
And bus,
Do you,
etc. Different things. Yeah.
is there such a
Yeah.
thing as collision detection in any of the stuff that you've worked with, or is it all timing?
Well, there is a mode I have